Hello guys, welcome back to Maths on African Motives. We are still on our mathematics and this is the question paper which was actually written in November 2023. That is November 2023 exams. So I would like to thank those who have provided the questions so that we can be able to work on these questions that we can see here. So we shall work on this question paper, guys. Let us try to uh, work on everything up to the end and see how we're supposed to attempt these typical questions. If you've got any other method that you used besides the one that I'm going to use to answer any certain question, but having same answers, that is the most important thing, okay? Then you can also share your method so that we can also work with that method on another video with others so that they also can learn from your method, okay? So I'm not going to waste much time, guys. Let us quickly rush through our questions and see what we're given. This was our first question that we're given, question number 1 and 1.1. We were given to solve for Q in the following equation by the factorization method. This is what is important. Do not just answer the question. Understand the method that they want you to use. Okay, this is by factorization method. And we are given our equation. I'm just going to write it here. Let's hope it's going to be fine. Our equation is given as minus 10q squared minus 11q plus 6 is equal to 0. This is the equation that we are given, which is a quadratic equation, all right? We are referring to trinomials in this case, whereby a trinomial is now giving us an equation the moment we equate to a certain value. We know that we could have used the quadratic formula, which is fine, but the question there was specifically asking us to use a certain method, which is what? The factorization method. That is the most important part. All right. But before you use the factorization method, if you check also here the coefficient of q squared, which is at 10, this negative 10, is having a negative, okay? We are having this as a negative. We can even avoid that. Remember, I told you to avoid this, just divide by a negative 1 throughout. Just divide by negative 1. Before you start your factorization, okay? So this is going to cancel here. So you have positive 10q squared. This also cancels. We've got a positive 11q, positive and negative. That's a negative 6, which is equal to, all right, if a 0 is divided to a number, it remains as a 0. It's not a positive, it's not a negative, all right? So remember, what I said about your factorization is that when you're given this type of a quadratic, whereby the coefficient of the first part, the first term, which is the one that is having the exponent of 2, if we are to have it in the form of ax squared, remember our format, ax squared plus bx plus c must be equal to 0 if it is a quadratic equation. So if this one, the coefficient there is not equal to 1, we are going to have a longer way where we multiply the first two, the first term and the last term. So we're going to multiply these two. The first term, we multiply it to the last term. Okay, that's 10q squared multiplied to negative 6. All right, so this is going to give us negative 60. If we multiply 10 times negative 6, that's a negative 60. But we're going to have negative 60 q squared. Then I told you that you're going to need the factors, which are called the product. So here you are going to need the factors, or we are simply talking about what? The products. In this case, two numbers. There must be two numbers or two factors that you're going to consider. That if you multiply these numbers, because we have got this number here that we have. So if we multiply the two terms, they must give us negative 60q squared. But these products or the factors that we're talking about, if we add them, they must give us this term, the middle term, which is 11q. So this is the most important part that you are supposed to consider here. the products or the factors that we're talking about, they must give us this. They are the factors of this. The factors of what? Of negative 60q squared. But they must add up to the middle term. This one in the middle term, they must add up to 11q, and it's a positive, this one. It's a positive that we have. So meaning to say, we are going to need the factors of 60, right? The numbers that you multiply to get 60, but considering also the sign that it's a what? It's a negative. All right. So there are so many numbers that you can consider. We've got 6 and a 10. If we get this as a negative 6, or we can have this as a negative 10 this side. We've got 15 and 4, right? 15 and 4, which can be negative 15, or we can have this as a 15 and a negative 4. Why am I putting a negative on one of the numbers? It's because the product there is a negative. So you're going to try as many numbers as you can. There are so many numbers. You try 12 and 5, which can be negative 12 and 5. You try 12 and negative 5. Remember, this method is called a trial and error. It's not like that is the name, but whatever that you're doing there is trial and error. You are trying. So do not consider one factor, then you're done. You have to try, list your factors down, all right, using your calculator, or you can just take your factors, numbers that you multiply to get what? 60. But in order for this, it must be a negative 60. That's why you put a negative. And here there's a Q, so we're going to put that Q later on. Let us focus on the numbers first. Okay, of these numbers that we have, which part that if we add, it must give us positive 11. Yes, it must be 11q. Shall talk about that, but let's focus on the number first, which is 11. Do we have a combination of the two that we can add to get 11? So you have to try add this part. If you add this, you're going to get a 4. If you add this part, you're going to get a negative 4. You're adding on the calculator. If you add this, you're going to obtain a negative 11. But if you add these two here, you are going to obtain positive 11. 15 plus minus 4, that's 11. So meaning to say this is the combination that we want, but we're just going to put the cube so that we match with the middle term that we have. So remember what I told you, that once you have those two terms, or the factors that we're talking about, that if you multiply, you must get this negative 60. If you add, you must get the middle term, which is the positive 11q. You substitute these two into the middle term. So this will be 10 q squared. We substitute this into the middle term. So this will be plus 15q minus 4q. We are taking these as they are. So this is minus 4q minus 6 equal to 0. So this will remain as it is, but we have taken these two into or in place of that middle term that we said if we are to add them, they must give us that middle term. But first, they were factors. So you'd start by finding factors before thinking of adding the numbers that gives you 11. There are so many numbers that you can add to give you 11. That's not the concept. We want those to be from the factors, from the products of the two. If we have from the product, then it means we are in the right direction. All right. So anyways, from this part, we can continue this by solving. Remember, by grouping into two of the brackets, we can see that here, if we group this into two, we've got a common term that is going to be affected in the first two. All right. What is that common term? Let us consider from the first two terms here, what is common? 5, all right, between 10 and 15. 5 is the highest common factor between q squared and q. Q is the highest common. Remember, the highest common factor, you take the one with the smallest exponent. So you can factor out 5q, and whatever that we factor out, we divide. So that's 10q squared divided to 5q, which is going to give us what? 2q in that case, all right? 10q squared over 5q like this. So this is going to be a 2, and q squared divided by q, there are 2 of them. If we divide, we're going to remain with 1q there. All right, plus we do the same thing, 15 divided by 5, which is a 3, q and q, they will cancel. So that is going to be just a 3, right? So if we divide by 5q, this one, and this one cancels, okay? They're the same. So 5 into 15, that's a 3. So remember that I said whatever that you obtain in this bracket here, it becomes like the control of your factorization. What am I trying to say? If I'm saying it becomes the control, it means the second bracket is or must be the same as this bracket that we see here. So what are we supposed to factor out from these last 2 terms that we see, so that we have the same bracket as this one? That first thing is a negative, so that if we factor out a negative, it's going to be a positive, all right? So if we factor out -2, we are going to have this as -4 divided to -2, which is a +2, -6 divided to -3, which to -6, which is a +3. So remember here we're just dividing -4q over -2. This and this cancels. This gives us 2, so that's 2q, right? The same thing, -6 over -2 is going to be a positive. You can also do that on your calculator to test this. All right, so this is an equation. This is not just factorization. We are supposed to have this as an equation. So this is equal to 0. So remember, as we are focusing on our factorization on the left-hand side, okay, so what is the concept of our factorization? The 2 brackets are the same. So we are going to factor out the common bracket of 2q plus 3. If we factor out this bracket, what is it that exactly we are going to remain with? Because we've got this as our common bracket, this as our common bracket. So if we are to take it, or if we are to remove this part, what are we going to remain with? That is the question here. We're going to remain with 5q. So that will be 5q. And here we're going to remain with a -2. This is equal to 0. So one of the 2 brackets is supposed to be equal to 0. Remember, from your 0 product, the product of 2 numbers to be equal to 0, one of those numbers must be a 0. So that means you're going to have 2q plus 3 being equal to 0, or 5q minus 2 being equal to 0. So that means our q is going to be what? If you take this to the other side, it becomes a -3, then we divide by 2, all right? Or we're going to have, if we take this to the other side, we're going to have this as a +2, all right? So 2 is going to be positive, then we divide by the 5, all right? So these were the possible values of q that we can have. So as you can see, in our factorization method, there are so many ways of factorizing, or so many ways to get the first factors that you're going to consider, depending with how you can work out your factorization. All right, so it can be also a trial and error thing. When I'm saying a trial and error, is that you understand the concept of your factorization, how it is supposed to be like. So instead of you applying this part of factorization, you can also consider working with the brackets. The way that you understand your brackets, you can also do that. So it can be a simpler thing, or we can also do this thing. All right, there's another simpler way of doing this factorization. If you are actually someone who is understanding fast, but you want to consider, because all this part, if you check properly on our factorization, you saw the part that we had those 2 brackets of 2q plus 3 like this into 5q minus 2 like this is equal to 0. That is where you're getting your first mark. So they don't even consider how did you get these brackets. They don't even consider that. How did you get these brackets, or so forth? The first mark is there. that you're getting. So we can consider that to say, if they do not mind us having this bracket this way, therefore, let us use what we are used to get those same brackets. What is it that we are used to? All right, I want you to see this. Minus 10q squared minus 11q plus 6 is equal to 0. You understand maybe this method also, because you are used to the quadratic formula. All right, this is what you are used to. You are used to the quadratic formula. So, but you want to solve this. All right, remember we said we're going to divide by negative, and after dividing by negative, we saw that we are going to remain with 10q squared. This negative gave us positive 11q. Negative 6 is equal to 0. So, like I'm saying, since you are used to the quadratic formula, you are going to take in your quadratic formula to find the values of u. But since this is something that you are not considering as part of your question, even there is no need for you to show that you are using you are solving a certain question, or you are using the quadratic formula. It's something that you can just also do on your calculator. What you just need there are the solutions. Though that is the most important part. What you need are the solutions. So this is what you're going to do. All right, I'm just going to take you through. The calculator. Remember your quadratic formula. Do not forget your quadratic formula. It states that we're going to have minus b, right? So we are going to have x is equal to minus b over this and that, right? So our minus b, which is 11. So that's minus 11 plus or minus, we're going to have plus the square root of b squared, our b, which is 11. So that will be 11 squared minus 4 times a, which is 10, times c, which is negative 6, like this, over 2a, which is 2 times 10. So that's 2 times 10, right? You have used your quadratic formula, you get 2 over 5. This is the value of q, all right? So this, maybe just write it somewhere. Q is equal to 2 over 5, or q is equal to this, okay? I want you to see this method. It's another method that you can just do that part of factorization, because remember I told you that they just have the answers there, and this is minus 3 over 2. Okay, this is you in exam. We have obtained these two answers here, but you know that you are using the quadratic formula, but you want to make it look like you are using what? Factorization. This is what you're going to ask yourself, because you understand that I had a certain answer here to say this must be equal to 0 here. Okay, I want you to see this part. In order for you to find the values of, let's say you want to find the values of x, like this. What do? Each of these brackets must be equal to 0. X plus 3 must be equal to 0, or x plus 4 must be equal to 0. Then you take this to the other side, it becomes a negative 3. Or you take the 4 to the other side, it becomes what? A negative 4. So we want to do a reverse from these solutions that we see here back to these brackets. This is what I want. That is what you just want. So meaning to say here, to avoid that, there is a fraction. So you're going to remove that. This is same as over 1. So you just calculate it aside. 5 times q, all right? So let me do this way. So here, you're just going to multiply like this, cross multiply, all right? So that's 5 times q, which is 5q. Then 1 times 2 this side, which is going to be equal to what? Which is going to be equal to 2, all right? But this must be equal to 0. So you're going to take this 2 to the other side. We've got 5q minus 2, which is equal to 0. So that's your bracket. Okay, remember it is the bracket that you had to equate to 0 that you had before. X plus 3. X plus 3 is equal to 0. X is equal to minus 3. So it is the same thing. Even here, you do the same thing. You're going to cross multiply 2 times q, which is 2q. 1 times minus 3, which is minus 3. Take this to the other side, it becomes what? 2q plus 3 is equal to 0. Remember, this is exam, and what you are focusing on is that I just need to have two brackets. So all this is, you're not even supposed to show it because they said using factorization. So what you're just going to show them is this. You take this part, 5q minus 2, and you also take this part, 2q plus 3 in a bracket must be equal to 0. You obtain your 4 marks from there. All this procedure, all this part that you've used the quadratic formula, all this, they won't even see it. What they are seeing are the 2 brackets, and that is where the first mark is being given in exam. So then from there you can solve. All right, so I just hope we also understand some of the other tricks that can be used in exam. But anyways, this is just a revision on what we wrote. But for those who are to write next time, if you are doing N1 and you're revising for N2, this can be of advantage. All right, anyways, 1.2, it was given. A boy added twice his age to his mother's age and got 50 years. All right. He then subtracted twice his age from 8 times his mother's age and got 220 years. How old is the boy? And how old is his? There are 2 questions here. How old is the boy? And how old is his mother? So we need the 2 ages here. All right. So we've got the first reference that we have is given on the boy's age, and the other one on the mother's age. So meaning to say we've got 2 different ages that we are given here. All right, so let's put them this way because they are 2 and they're different, the boy's age and the mother's age. So we're just going to let the boy's age, all right, so we're going to let the boy's age be what? Be x, all right, and the mother's age and his mother, we'll just say this way, and his mother's age be what? Be y. All right. So these are the 2 ages that you're going to consider: the boy's age, which is x, and the mother's age, which is y in this case. Okay, so let's get back to the statement. They are saying a boy added. Remember, we are saying his age is x. So they are saying he added twice his age. Twice means 2 times. That is twice. 2 times, that is 2 times. So if his age is x, it means 2 times x, which is 2x. That is 2 times. Twice, right? So he added twice his age to his mother's age. So he's adding, this is twice his age, all right? So let us add his age, which is twice. So it's going to be 2 times plus he added to his mother's age, and his mother's age is what? Is y. So he's going to add twice his age, he add it to the mother's age. What is he going to obtain if he add? If he add this, he's going to obtain 50. So that's an equation there, because this is equal to 50. We have formulated an equation by just having an equal sign. All right, let's just leave it like that. Let's move on to another statement. Then now they are saying here on this part, he then subtracted, take note, twice his age, again, twice his age, which means 2 times. We are still on 2 times. But he is subtracting twice his age from 8 times his mother's age. Remember, I said whenever there's a times, you multiply. So 8 times means 8 times his mother's age, which is 8y. So this is going to be what? 8y. So he subtracted his age from. What does it mean? From. It means this one, 8y, is going to subtract 2x, which is twice, all right, to give us what? 220. This is from, okay? He is subtracting his age from his mother's, all right? From 8 times his mother's. So his mother's age, first he has to be multiplied by 8 because they are saying it's what? 8 times. So it's 8 times his mother's age minus twice his age, it must give us 220. All right, so that's an equation that we're going to formulate again from that statement. So we ended up with 8y, 8 times his mother's age minus twice his age. It must give us what? 220. So we've got two equations that we can consider to be solved in this case. Because in order for us to have the boy's age, it means we are finding the value of x, because x represents the boy's age. If we are to calculate his mother's age, it means we are calculating the value of y, because y represents mother's age or his mother's age. So it's up to you the method that you're going to use, all right? But here, as for me, it was going to be easier to just use substitution and make y the subject from equation 1. So from equation 1, we're just going to make y the subject there. So from equation 1, it means y is equal to what? We transpose 2x to the side, it becomes what? A negative. So that will be 50 minus 2x. So we can just call this equation 3. So we are going to substitute this equation 3 into equation 4, into equation 2, sorry, in this equation 2. You do not substitute, you have made the subject, I talked about this, all right? So you're going to substitute equation 3 into equation 2, all right, into equation 2. So if we substitute this, it means here in place of y, we are going to substitute 50 minus 2x, right? Take note, wherever there is a y, we're going to substitute what? 50 minus 2x. So let's do that. So that is going to be 8 into y in this case, which is 50 minus 2x. This is what is representing y. So that's 50 minus 2x, all right? Then here we already have this, so just going to rewrite in terms of x as it is, and this is equal to 220. So that's, we have formed an equation that only has x. So it's going to be an advantage because we only have x, only x. And it's a linear equation that we see, so we can just expand the brackets. 8 times 50, this was going to give us 400. 8 times negative 2, which is negative 16x, negative 2x is equal to 220. All right, so this part you can just collect your like terms, and also at the same time, we can transpose this to the other side, all right? So if we transpose 400 to the other side, it becomes a negative there, because it's 220 minus 400, and that was going to give us negative 180, right? So it divides by negative 18 by negative 18 both sides, all right? So that's going to have your x. This was going to give us a 10, all right? So if x is equal to 10, to find the value of y, like I always say, you can substitute in any of these equations, equation 1, equation 2, equation 3. But of all these equations, you're going to see that equation 3 is the best to use because already y is the subject here. If you check from equation 3, all right, if we check from equation 3, we can see that it's easier for us to solve for y because already it is y that you've made the subject, okay? Y is the subject of the formula, and you're just going to substitute y is equal to 50 minus 2, that is 2x, and your x in this case is what? Is 10. So this is 2 times 10. So that means you're going to have 50 minus 2 times 10, which is a 20. I'll just use a calculator here, guys. There's no need for you to write this stage by stage, no. So y is going to give you a 30 in that case. All right, so that means in actual sense, x represents what? The boy's age. Remember, I said the boy's age is what? Is x. All right, so if the boy's age is x, therefore the boy's age is x, which is 10. So it's going to be 10 years old, and his mother's age. So you're going to also talk about what? His mother's age is what? Remember, his mother's age is represented by y. And y in this case is what? Is 30. So this is going to be 30 years. So that is how we're supposed to have this. It's just solving of normal simultaneous equations, but instead of them giving us the normal simultaneous equations that we are used to, they are now just trying to give us this in form of word problems. So you have to solve a word problem. But as you can see, it was just formulation of equations from the word problem that you're given. So like I always say, this word problem that you see here is going to be different from another one. You need to understand what the question is all about. That is how you answer your word problems. All right, 1.3. Solve for k in this case. All right, so this is just a linear equation. We can just consider expanding our brackets. In this case, this was just 2 marks, right? So you can just consider expanding the brackets and collecting like terms. This is same as there is a 1 here. So this is going to be k, 1 times k, which is going to be k, 1 times 3, which is 3. So 1 is multiplying everything inside the bracket, same as minus 9. It multiplies everything. So it's minus 9k, minus 9 times 2, minus 18, which is equal to 118. So from there, we can collect our like terms. This is 1k, this is 1k. So we're going to have 1k, 1k, and minus 9k. So we're going to add this 1 plus 1 minus 9 in that case. All right, so let me just have this direct, because we're just going to add here. So that's 1 plus 1, which is 2, minus 9, which is a negative 7. So this is going to give us negative 7k. All right, combine the numbers. This is 3 minus 18, which is minus 16. So you're going to add 3 minus 18. That's negative 15. Which is the advantage of using a calculator. You can just make a small mistake. All right, so here you can transpose negative 15 to the other side so that it can be a positive 15. So it will be 118 plus 15 on the other side because it was a negative. Once you take it that side, it becomes a positive. So that's 133. So to obtain the value of k, you can just divide by what? By a negative in that case, all right? By a negative 7. So if you divide by negative 7, this answer is going to be negative 19. All right, so that was the suitable value of k that we could have obtained from solving this linear equation. All right, so that's a linear equation, 2 marks for that. All right, then on the other part, they are saying here, given this formula, that we have, make A the subject of the formula. From this formula that we see, we are supposed to make A the subject of the formula. All right, let us just have this question aside so that we can properly see it. That was question 1.4, where we are given that f is equal to the square root of, that is 7 over A plus h squared, like this. All right, and what we want here is to make E the subject. All right, how can we do that? How can we do this? Okay, let us consider this to say the num or the letter that we want to be the subject, which is A, is inside of the square root. It's actually inside of the square root here. So what are you going to do? You're going to just square. Remember the opposite of the square root. You're given the square root. In order for you to remove the square root, we have to square both sides. Whatever that you do on the left-hand side must be done on the right-hand side. So if you do whatever on the right-hand side, let it be done also on the left-hand side. So if we square this, we are going to have f squared is equal to, here the purpose of us having this square, it was to remove the square root, the opposite of the square root. Remember, the square root means the exponent of a half. So if you multiply a half and a 2, you get a 1. So it means we are not going to have this square root. We are going to just remain with the terms under the square root as they are, 7 over A plus h squared, as they are not being affected. You do not find the square root of h squared. You do not find the square root of anything. All right, remember that you want to make A the subject, so you can transpose this to the other side of the equation because we do not have E, so you can just take it to the other side of the equation, so it becomes a negative. So that's f squared minus h squared is equal to 7 over e. So if we take this to the other side here, becomes what? A negative. So this is the negative that we see here. And we can also cross multiply, all right? This is same as over 1, remember? So the purpose of cross multiplying is to remove what? To remove fractions. We have to clear our fractions in this case. So you can multiply by e this side or just cross multiply. But if you cross multiply, you take this as a single part. So the whole of this part is going to be affected by e. So it's e into, so it's going to be e, you open the bracket, which is going to be f squared minus h squared. This is to show that e is supposed to multiply everything, all right? And this is equal to 1 times 7, which is a 7. So as we can see, what we just want, what we need to make the subject is already clear here, which is this e is just being affected by the bracket, which is multiplying. So how do you remove the bracket that is multiplying? You simply divide by that bracket. So if we divide by f squared minus h squared both sides, f squared minus h squared, it means we are going to remain with e. So therefore, our e was going to be equal to 7 over f squared minus h squared. Okay, so that is how we could have played around with this question. Like I said, guys, change of subject or to manipulate the formula, there are so many different ways that you can play around with the question. So many different ways. What is important is that of all those ways that we talk about, this is the only important part that you're going to have to prove that our answers are the same, or whatever that we calculated means the same thing. We are supposed to have the same answers when we calculate the value of e given now the values or the value of f and the value of h. We are asked to calculate the value of e. So by calculating this value of e from these two values that we are given, we are supposed to obtain same answers if we say our formulas are the same. But if we get different answers now, it means they are not the same, right? To be the same, they must give us the same value of e. So this is how you can prove that your answer that you're having is the same if you're having the same answer as what you're going to get here. All right, so our f is 13 and our h is 3. All right, so remember that we are given that f is 13 and we want to calculate the value of what? The value of e. So that's 1.42, given that f is 13 and h is equal to 3. So this is just a substitution that you're simply making because you already have e as the subject. So e is going to be equal to 7 over f squared. So our f in this case is 13. So this will be 13 squared minus h squared. Our h in this case is what? Is 3. So this will be 3 squared. So that was going to give us the answer or the number that represents what? E in this case. And you can just use your calculator for that. That is 7 over 13 squared minus 3 squared, like this. 7 squared by 13 squared minus 3 squared, which is going to be 7 over 160. So this is 7 over 160. So this is how we could have played around with this question. So if you're obtaining the same answer like this, which is something like 0.04375, obtain the same answer like that, it means this answer that you have here is the same. But if you're getting different answers like this one from the answer that you've made in the subject, it means that answer, guys, is wrong. Redo it again. All right, that's how you can also mark yourself to say if you're in the same direction with what we are doing here. All right, on question 2, it was simplification of our fractions as usual. All right, so this is 2.1. So here I've got two different ways that we can consider this. 2.2, 2.11, we are given this part, okay? simplify the following algebraic fraction, and this is what we have 6 marks for that. Okay, so like I said, there are different ways. I'm just going to consider different methods. I'm just going to consider 2 different ways of answering this. They both use the same thing, but just differently presented. Okay, they're just differently presented. What is it that I'm trying to say? Okay, we are given 3a minus 1 over, this is a plus 4, okay, plus 8a, everything over a squared, plus 3a minus 4, like this. Okay, this is what I want you to understand. Remember, when you're dealing with addition and subtraction, what you're going to need is what? Is to find the LCM of the given denominators, or what you refer to as the LCD, the lowest common denominator for the given denominators. But that must be found if we've got our algebraic expression in a factorized manner. So meaning to say here, there is something that has to be done. We have to factorize first before we think of that LCD. Okay, so let us just rewrite everything as it is. 3a minus 1, there's nothing we can do. On a plus 4, there's also nothing. There's nothing that we can't factorize that one. Okay, so plus, we're going to have 8a on top over. So this one is just a direct factorization. Remember that we've got the coefficient of a squared being a 1 in that case. We're just going to consider 2 brackets. Then we've got our a and our a in this case. So if it is like this, and I said you have to consider the factors or the products of the constant. So they just consider your constant, which is -4. Just need 2 numbers that we multiply to get a -4. But if we add the numbers, we must get a +3. If we add, we need the product. Product must be -4. Add, it must give us a -3. So we've got -4 and 1. We've got 4 and -1, -2 and 2. So there's so many. All right, but these are the ones that we have. But which part that when we add, we're going to get a +3. So this is the one that was going to be the best answer that I need. Okay, let me explain this, what I'm trying to say. I'm saying I need 2 numbers. Like if I multiply the 2 numbers, 4 times -1 like this, these are the numbers, okay? I get a -4, which is this one. But if I add these numbers, if I remove this and add like this, I'm going to obtain 3, which is this number. That is what I'm trying to say, okay? So if these are the 2 numbers that we have, and if we add them, they give us a +3. So we've got +4 and -1. So this is a +4 and a -1. So meaning to say our LCD in this case was going to be what? A plus 4, they are common, just appearing once here. Here it's also appearing one time. Here it's appearing one time. So you just take it as it is. So you're going to take it as a plus 4. And also we've got a minus 1. Remember, the LCD is the lowest common denominator. It must contain all the terms. It's a multiple. It must contain everything in the denominator, every bracket that we see. All right. So if we consider the methods that we talked about on this edition, there's another one that I always talked about, whereby you have to take back your LCD to the fraction. All right. We're going to take our LCD, which is a plus 4. Like I said, I'm going to explain another one. Okay. A plus 4 here into the bracket of a minus 1. Then this is our whole scenario of answering this question that we've been doing before. We said we're going to divide our LCD to each denominator that we are given. All right. So if we divide here our LCD to this denominator of a plus 4, it will cancel because here we're going to divide by a plus 4 here. So already there's a plus 4. So a plus 4 and a plus 4 cancel. We remain with what? A minus 1. So the a minus 1 is going to multiply the numerator there. So it's going to be a minus 1 multiplies the numerator as it is, which is 3a minus 1. Plus, we do the same thing. Our LCD divided to the LCD. So as you can see, they are the same. They will just cancel this and this are the same. So it will give us a 1. So that's 1 times our numerator, which is 8a. So that is the condition of this question. Then from there, you can be able to expand your brackets here because you've got 2 brackets that you're considering. So remember, by distributing these brackets, a is going to multiply everything in the second bracket. So that's a times 3a, which is 3a squared, multiply again a times -1 here, which is going to be negative a. All right, we are done with a. Move on to -1. So that's -1 times 3a here. If you multiply these two, we're going to have minus 3a minus 1 multiplied to -1, which is going to be a positive 1. Okay, so we multiply everything. And on this part, it's plus 1 times 8, which is going to be plus 8a. Plus 1 times 8a, which is plus 8a. Everything over your LCD. So the LCD is just going to remain as it is. That is a plus 4 into a minus 1. Then from this stage, you can be able to collect our like terms. But as you can see, there's nothing having the highest exponent of 2. So you're just going to rewrite this as it is with the highest exponent of 2, which is 3a squared. Then you have to consider the part of a. This is negative a, which is same as -1, -3 plus 8. All right, so if we add this, that will be -4 plus 8, which is a positive 4. So that will be positive 4a, or just use your calculator, like I said. And there's only 1 there, so this is just going to write as it is. All right. So in actual sense, this is what you're supposed to have as your final answer. But this is a simplification, guys, that we know that we are supposed to factorize later on, because what we do not know is that, are we going to have the same brackets? Because if you factorize this part here and you obtain, I'm just putting an example, and you obtain something like this. All right, let's say this is what happened. It means you are going to cancel out this and this because they are the same. Okay? So meaning to say, in order for you to see that they are the same things, this has to be factorized. Our numerator, we have to factorize and see. So if we are to factorize 3a squared plus 4a plus 1, remember what we said, if this is not a 1, we're going to multiply the first term to the last term, as we did. So if we multiply this 3a squared and 1, this is going to give us what? 3a squared. So you're going to need the products or the factors of 3x squared. But these factors that you consider, or the products that you consider, which are the two numbers that you consider, if you add them, they must go back here. They must give you this, which is 8, which is 4a. So we are considering which two terms that we can multiply to get 3. Guys, 3 is just 3 and 1. There's nothing there. It's just 3 and 1. And if we add 3 plus 1, we get what? Get a 4. So instead of writing 3 and 1, we're just going to write as 3a and 4a, and 3a and 1a. And these are the numbers that we're going to substitute into the middle term. Remember what I did, guys, on that factorization. So we said the factors of 3a squared, which is 3a and 1a. Remember, 1 is same as 1a. 3, you're just going to put a and a, so that if we add 3a plus 1a, we get what? 4a. So this is same as 1a plus 1. So from the first two terms, remember I told you by grouping, factor out 3a, it's going to be 3a squared divided by 3a, which is a. 3a divided to 3a, this will be a plus 1. Already we have a plus 1, and we are supposed to have the same thing, the same bracket of a plus 1. So you're going to factor out plus 1. Remember I said you factor out what will make these brackets to be the same. So you're going to factor out plus 1. Then we remain with a plus 1 as it is. So the two brackets are the same. We've got the bracket of a plus 1 here, and we've got the bracket of 3a plus 1. So this is what we're going to have at the end. So meaning to say, unfortunately here, there's nothing that is going to cancel, but you're supposed to have this because you never know what will happen. Sometimes you find out that these two brackets are the same. If there was a condition like that, like what I showed you on that example, then you have to cancel the brackets. But in this case, if you consider here, there's nothing common between the numerator and the denominator. So there's nothing that you're going to cancel. You just have to leave it like that. All right. You have to just leave it like that. All right. So like I said, there are different ways of answering this question. And from the previous case, this is the method that I've been explaining mostly. And we have like worked with this method a lot of times, and now we understand it as much as we can. All right. This is another way that we could have worked out this way. To say, if we understand, I want you to see this. I explained previously that if I've got two numbers, 2/7 plus 3/7, okay? As long I'm in a way that these two are the same, it means I can simply add the numerators together, 2 plus 3/7. It's just because we are having the denominators which are the same. So you can add these numerators. That is a direct way because these two numbers are the same. So it follows that if I have A over B plus C over B, it means I'm going to combine this, which means I'm going to obtain as A plus C over B. Because B is the same. It is the same. So in order for you to have the same, because we know that if they are the same, we can simply add or subtract. So we're going to try to do that to have the same denominators here. So this is what is going to happen. 3a minus 1 over a plus 4 plus 8a over, remember here we factorized and we got two brackets, which are these ones, a plus 4 into a minus 1. So this is what you're going to do. You ask yourself a question like, since I want to make these denominators to be the same, I simply have to ask myself to say, what is it that I'm supposed to do on this side so that it gives me the same as what I have on this part in the denominators? So you just have to focus on what you do not have. What is it that I'm not having that is on the other side? Okay, I do not have a minus 1 here, but here there is a minus 1. On my LCD, there's a minus 1. So what I do not have, I multiply by it. So I'm going to multiply by a minus 1 over a minus 1. So you multiply by that, both the numerator and denominator, so that you are simply multiplying. It's like you're multiplying by 1. So you haven't changed the meaning of the question. But what now it means is that this is the same as we've got 3a minus 1 like this into a minus 1 over a plus 4, all right, into a minus 1. But do not cancel this, because if you cancel, you have neutralized your question back to where it was. Remember, doing this, we just want to make sure that these denominators are the same. So on this part, is there anything that I do not have here, but it's there on the LCD? There's nothing. Everything that we have here is already there on the LCD. So on this one, there's nothing that I'm going to do. I'm just going to rewrite as it is. So this will be a plus 4, a minus 1. So if you just understand this to say, you just have to make the denominators to be the same. So you take what you do not have from another denominator, put it to another denominator, but whatever that you do to the denominator, it has to be done on the numerator, remember, so that it does not change the meaning of the question. So that you are simply, because you are like you are just multiplying by what? By 1. Once you're at this stage, guys, remember what I told you is that these, once they are the same, we can combine our numerators together. So it means we are going to have 3a minus 1, all right, into a minus 1 in this case, all right, into a minus 1 plus the 8a that is, as you are just taking everything as it is and everything over what? A plus 4 into a minus. You're just taking everything as it is. Remember, I said once the denominators are the same, you can combine your numerators. So this is it. As you can see, once you're at this stage, you are back to the last stage that we worked about from our previous question. So this is now the same, where we expanded this and collected our like terms, this and that, and we ended up having something like 3a squared plus 4a plus 1 after expanding everything, and then also do your factorization, which that one is, it will remain the same. But what I wanted you to see is that we can have, or we can add this part here, okay, avoiding to divide with the LCD back, to say LCD divide by the denominator, then whatever you get to multiply, LCD divide. You can avoid that by just making your denominators to be the same. Once they are the same, you just combine your numerators as they are, everything over that common denominator that we see, which is the same throughout, then everything, the rest is the same. All right, so I just hope you understand that one. Like I said, different ways of attempting these questions. All right, on 2.12, it was again to simplify, and this is 4 marks on that one. Given n squared, I think this one we can even just do it here, the space here. All right, so the first thing that you're gonna consider before you even forget here, remove that division that we see here. All right, so remove that division, put multiplication. So this was gonna be n squared minus n over n minus 2. Then if you remove the division, introduce multiplication. So you're gonna be multiply, you interchange, you tip the second fraction, just interchange that second fraction. So it means n squared minus 4 is going to be on top on the numerator. Gonna have n squared minus 4 over the denominator is going to have n squared minus n minus 6. Okay. So meaning to say here, you're gonna consider n squared minus 9. This is a difference of 2 squares. Remember from the concept of our a squared minus b squared. All right, we've got a squared minus b squared. This would be a minus b into a plus b. So that's here. We're gonna just consider the square root of n squared, which is n, minus the square root of 9, which is 3. So this will be 9, n minus 3, and also n plus 3, everything over n minus 2. Multiply to, okay, there's nothing that you cannot do, it's already in simplest form, okay? Then n squared minus 4, another difference of 2 squares, okay? So the square root of n squared, we said is n, but the square root of 4, which is a 2, so it's going to be n minus 2, another bracket, we'll just add what is in the first bracket, okay? This is over, we have to factorize this n squared minus n minus 6, but it's an advantage because here we just have to consider that here's 1. So we're going to consider here there's n here. So let us consider factors of negative 6. What are the factors of negative 6? But if we add these two numbers from negative 6, they must give us negative 1. So there is supposed to be negative 3 and 2, okay? There are so many numbers that you can multiply to get a negative 6, but the one that you're going to add and get a negative 1 here, guys, it'll be what? Negative 3 and 2. So just try those vectors. Like I said before, it's a trial and error thing. So you're going to try vectors, this and that, okay? So later stage, you can just divide as long. Remember, I told you as long it is between the numerator and the denominator, you can be able to reduce your terms in that case, okay? So we've got n minus 3 here in the numerator, n minus 3 in the denominator. All right, we've got n minus 2 in the denominator. We've got n minus 2 in the numerator. We've got n plus 2 in the denominator. We've got n plus 2 in the numerator. All right, we do not have anything related to this n plus 3. So in the numerator, we are going to be left with n plus 3 over 1, which is the same as what? As n plus 3, okay? So that was it, yeah, 4 marks for that, which is something that was nice. Okay, question 2.2, given the following algebraic expressions. So these are the algebraic expressions that we have 7 marks. Okay, factorize each expression completely, and that was 7 marks for that. Okay, so these are the expressions that we're given, and we're asked to factorize them each completely, which is fully. Factorize what? Fully. Okay, anyways, let's see. The first one that we are given, it's 3p plus 3q minus 9 minus pq. If we are to consider that concept of grouping, because there are 4 terms that you consider here, got 1, 2, 3, 4 terms. So if we are to consider the concept of by grouping, you're going to see that it was going to be difficult for us, because here we can factor out a 3. Okay, do not take this in mind. I'm just showing you. You're going to factor out a 3, you get p plus q. And here there's nothing common that we can factor out to get that p plus q. So it means there was a need for us to rearrange first on this one. There was a need for us to rearrange before we talk about what? Before we talk about the factorization. So let us rearrange this. What can we do? We can just take a part that is something in common. Like in this case, if I'm going to take 3p and 9, then the q, this part with q here. Right, so let me just rearrange that way. Here we can arrange that way. So this was going to be equal to 3p minus 9. So you're going to take minus 9 to be closer to 3p. All right, so it's going to be minus 9. And we can take this 3q because we want also to remain with a positive, a 3 at the end. So we can start with the minus pq, all right, because these two, they are now together. But we can rearrange as minus pq like this. We take this one to the other side like this. So also you must have an insight of what is going to happen later on, because later on, if you factor out a 3, the 3 is going to remain this side. That's why I had to take the 3 on this side, because we're going to remain with the 3 on that other side there. All right. So this was just rearranging. Now that we have rearranged, let us group them into 2 and see if we can able to win. Because remember, I told you if you group them into 2 like this, you can factor out the highest common factor between the 2, and yet between 3p and 9 is just 3. So you're just going to factor out 3. 3p divided by 3, this will be a p, that's 3p divided by 3. All right, minus 9 divided by a 3, which is going to be a minus 3. So we are supposed to obtain the same answer, p minus 3 on this side. But if we consider the part of p is carrying a negative, and the p here is supposed to be a positive. So what are we supposed to do? We are supposed to factor out a negative so that it can be a positive. And so that is the common term, which is q. So the minus q will make this to be a positive, because it will be minus divided to a minus, which will be a positive. Yes, q and q cancel, you remain with a p, but it will be a positive p because negative, negative. Here, positive, when divided to a negative, it gives us a negative. So 3q divided by q, q and q will cancel. You remain with a 3. So that's it. That's it there. Okay. So that's it on this side. So meaning to say, we're just going to take the common bracket, which is p minus 3, p minus 3. That's our common bracket here. So we're going to have p minus 3 in this side. And here we are going to have 3 minus q. All right, this will be 3 minus q like this. But we all know that later on we are going to determine the HCF and the LCM. And these must be in simplest form. And in order for you to be able to realize that this is the HCF or this is the LCM, we must have a certain order that you need to follow. If you are writing x plus 3 like this, it means you are starting with a variable followed by a constant, and another term is given as minus 2 plus x. You can just rearrange this to be written as x minus 2 because you want to write it in a way that you understand, seeing x on the first term because it's a variable. So this is the same thing that is happening here. Yes, p, it's a variable, which is fine. It's on the first term. But if we consider this bracket here, we are going to see that we need to work on this bracket because on this part, q is supposed to be on the first term, and not just to be on the first term, it must be a positive. Okay, let me focus on this. The p minus 3, let me take it this side. I'm just going to focus with this. We are going to take q, so it's going to be minus q plus 3 like this. Okay, p minus 3, I'm not going to affect this, just going to remain as it is because already it's starting with a variable p, a letter, which is letter p, and it's a positive. But this here, the way that I've changed it to write it on the first bracket, I just want you to focus on it only because this one is already fine. So I want to focus on this here. So what can we do? Because it was 3 minus q. We haven't changed anything because q is still a negative, as you can see. 3 is still a positive, as you can see. But we are supposed to remain with the term inside or the letter inside the bracket as a positive term that is to be fully factorized. So what are we going to do in this case? We are going to consider the negative out. So we're going to factor out the negative in this case, all right? So here we are going to factor out the negative that we see. So if we factor out this negative here, we take it outside of the bracket. It means we are going to remain with negative q divided to a negative. It becomes now positive, okay? 3 divided with a negative, it becomes a negative 3, all right? The p is not even affected and it's minus 3, these two. That's why I said, let me write them at the end so that you can properly see this. They are not even affected by anything. They are not even affected. All right. So we have factorized. This is the last extent that I want our answer to be like. Okay. So here, let us just write our final answer as what we got here. So this gave us negative bracket q minus 3 into p minus 3. So you're going to need this because remember, you're going to need to find the HCF and the LCM there. All right, the same thing was happening on this part. If you check the p, that part of 45, if we check this, 45 minus 5p squared. If you check this also, look where the p is. On the last term, and we are supposed to have this on the first term. To maintain this p, q, we are supposed to maintain that on the first term. So meaning to say, we can just start by writing this as negative 5p squared plus 45. There's nothing that we have done. We just rearrange these two terms, and there is no equal sign, so they just remain with their signs. Nothing is going to change its sign there. All right. So now that we want to make this p to be positive, what are we going to do? We are going to factor out the negative 5. The moment we factor out negative 5, which is the highest common factor, this divides negative 5 and negative 5 cancels. We remain with positive p squared. 45, when divided to a -5, it gives us a -9. For a number to be a negative, that one is not our worry. Our worry is when a letter is a negative, that one. A number, let it be negative, let it be positive, that one is not our problem. All right. Then, what can we do from this stage? We can see that there, we are back to our difference of two squares. P squared minus 9, we can determine their square roots. The square root of p squared, which is p, then I have p and p. The square root of 9, which is 3, so this will be -3, and this will be a +3. So meaning to say, we are having this now as our final answer, -5 into p minus 3 into p plus 3. Okay, so this is how we're supposed to factorize this one. All right, then the last one, this one is just direct. Remember, I talked about this. If the coefficient of this 1, just gonna have two brackets. So this will be p, this will be p, so to give us p squared. So we focus with the constant, which is 18. What are the factors of 18? But these should give us a -9. Factors of 18, you think of 6 and 3. 6 times 3 is 18. 6 plus 3 is 9. But to get a -9, it must be -6, -3. Right? Negative times negative, it's a positive. If we add -6 plus -3, it gives us a -9. So these were the two that I wanted you to have, p minus 3, p minus 6. All right. Anyways, guys, after you are done factorizing this and that, how then are you going to have the HCF? Because as you can see, 7 marks was just for factorization. And the 3 marks that we have are for the HCF and the LCM. So 2.22. The HCF, remember I told you it's the highest common factor and it must be common throughout the terms. We must have a common term. So here there's a negative. Here we do not have a negative. So negative is not common. Q minus 3, we do not have it anyway. P minus 3, P minus 3, P minus 3. It's common everywhere. There is P minus 3. So meaning to say our highest common factor is going to be P minus 3. That's the common bracket. Remember I said it's the common bracket throughout. P, not X, but P. So that was going to be the bracket of P minus 3. And I told you for the LCM, this one is just like that part of our fractions. When we talk about the lowest common denominator, what is it that you do on the LCD? You take every part that is, as long it has appeared, as long it's there, as long it's written, it must be on your answer. All right, we have a negative. We also have a negative, but we're going to take as -5. So we're going to take the negative, it's there. There is a bracket of Q minus, as long as it's there and it's appearing once, which is one time here, once here. So we're going to take that bracket of Q minus 3. The bracket of P minus 3, we have it here. We also have it here. We also have it here. That one is not a problem as long it's appearing once on each part. Here it's appearing once. So we just take it once also on our answer here. If there are many, you take where there are many brackets of P minus 3, okay? We move on to the bracket of P plus, it has appeared P plus 3. We can see it that there's a bracket of P plus 3. It has to be there on our final answer. We are going to also have P plus 3. And also the bracket of what? Of P minus 6. So you're going to have the bracket of P minus 6, just like that. So as you can see, the LCM, it carries everything that is here. It must be there on your, if you see a bracket that you wrote here and that bracket is not here, it means it's wrong. A factor is the one that you must take something that is just common. This one, the P minus 3, that is just common throughout. That is for the HCF. But the LCM, it must be everything that you are seeing or everything that you have factorized before the brackets as they are. You must take those brackets as they are. So these are the typical questions that you're supposed to be expecting. Right. Let's check the other part. Just have to be careful when you're answering your questions. That is the most important part. Okay. So anyways, on question number 3, we were given in this part 3.1, simplify the following without using a calculator, meaning to say this part, they do not need a calculator. And if you check 3 times 3, that is each part at 3 marks. Okay, so the first part, these are logarithms. Logarithm, oh, let's check. Okay, let us just try to have our question wave for a space and see. So the first part, which was 3.11, it was given as the logarithm of, okay, it was the logarithm of a certain logarithm again. The logarithm of 512 like this, which was in base 2, and this was in base 3, okay? Plus, in this case, we've got the cube root of, this is 2 and 10 over 27. Okay, so that was our question here. Okay, this question. So let's see. Yes, we are told not to use a calculator, but in your simplification, guys, whatever that you're going to do here, it's not like they are going to know that you have used a calculator or so forth. All right, no. We know that from our logarithms, we understand that the logarithm, when we have something of this nature, the logarithm of a in base of a, it must give us a 1. If the number and the number are the same, if we've got those two which are the same, we're going to get a 1. And also we understand that if we have got a certain exponent on a log, let us just say we've got the logarithm of a in base of b, this is being raised to the exponent of m. All right, this is being raised to the exponent of n, okay? Or let us just use m so that we do not confuse each other. We are going to drop this exponent. So it's going to be m, the logarithm of a in base of b. So it will be the exponent to multiply the logarithm. These are the most important laws that you're going to need to answer this question. And also the last one, which I also explained previously, that let's say we have got the same base. We've got two numbers. They can be in the same base. Okay? They can be in the same base. A and A, like this. A to the exponent of m, and also A to the exponent of n. All right, so what happens when they are exponents like this? That a number is raised to a certain exponent, and also a base is raised to a certain exponent. This will give us, okay, we drop the exponent here, it multiplies this one on A, but this one on A on the base, it divides, all right? So this will give you m over n. It will be m over n. Remember, we're going to have log A base A. But I said here, log A base A gives us what? A 1. So it means this whole part is not going to work for us, right? This whole part here is just going to be m over n, because log A base A gives us a 1. All right, so those are things that you must consider that. So if we have that in mind, we can start by thinking of this logarithm of 512. All right. How can we write the same 512 in the smallest number, which is 2, in the base of 2, so that at least we can have a condition where we can drop the exponent and we understand log A base A is equal to 1. So that's why we're thinking of making these two numbers to be the same, so that we work with something easier for us. All right, so let's consider that. We are in base of 2, so you consider 2. Let's say do not use a calculator, but no one is going to know that you have used this calculator to simplify 2 to the exponent of a certain number, trying to get 512. So it's going to be a trial and error. You try a 7 like this, you're going to get what? if you try a 7, this would be 128. You try again 2 to the exponent of an 8, which is 256. You try 2 to the exponent of a 9. This will give you 512, which is this one. So that means we've got the logarithm of 2 to the exponent of 9 in place of what? 512. It's the same as 2 to the exponent of 9 in base of 2. All right, I'm going to talk about this later on. Plus, let's come here. We've got the cube root of this number, which is the same as the cube root of, if we simplify this, we know that we are supposed to multiply, then we add 10. These two we multiply, then we add a 10. But we can also do that on our, no one is going to understand that you have used this calculator to simplify this part. So let's take this out. We're going to use this fraction here on this, on top. So it's shift, you press this one. So it gives you the whole number and the fraction. So the whole number is 2. Your fraction is 10 over 27, like this, which is going to give you 64 over 27. So this is same as called 64 over 27. All right, do not make a mistake of putting it this way to just write 2. Then you put a fraction like this and you, all right, sorry, you write your 2 like this, then you put a fraction like this. All right, is it gonna work, guys? Some of you do it like this. You say 10 over 27 like this, then you go back and put a 2. Never make a mistake. You see, it gives you a wrong answer totally. It multiplies when it is like that. So never put it that way. You have to use this fraction, the one for an improper fraction on top. So it's shift this one, okay? That's the one for an improper fraction there. So on this stage that we are given, all right, remember what I said about the exponent here, that whenever you're given this condition, it means we can drop the exponent. We had m as our exponent. Now the m is multiplying the logarithm. So it means here we are going to drop our exponent to multiply the logarithm. So that is going to be the logarithm in base of 3 of, if we drop this 9 here, it is going to give us 9, the logarithm of 2 in base of 2 like this. All right, plus we simplify, what is the cube root of 64? The number that multiplies itself to give us 64 3 times, which is what? A 4. The cube root of 27, which is a 3. If you do not know this, that one is not a worry. Again, you can simplify this. When they're saying do not use a calculator, they're saying do not just simplify everything at once. All right, so you just take your calculator, use that one, you can use it to prove your answer at the end. Okay, so this one you can just shift the cube root here of 64 over 27. So this is 64 over 27 like this, which is 4 over 3. All right. Anyways, we said at this stage, we are going to consider the logarithm of 2 in base of 2. Logarithm of a in base of a is equal to 1. This is what we have, 2 and 2. So the logarithm of 2 in base of 2 is going to give us a 1. So it means we've got 1 times 9, which is 9. So this is going to give us the logarithm of 9 in base of 3. Now we are no longer having these guys. We're just left with 9. So it's now log 9 base 3. Okay? Because everything is being affected by the log in base of 3. Okay? But not forgetting that here we simplified already. We simplified, we got 4 over 3. So we're just going to rewrite as it is, 4 over 3. Now we are back again. The logarithm of 9 in base of what? In base of 3. What is the answer? If you know this, you can write even the answer. Remember, it's 3 to the exponent of what, which gives us a 9. 3 to the exponent of a 2. So this is 2 plus 4 over 3. Or you can even simplify the logarithm of 9 in base of 3 is 3 to the exponent of 2. in base of 3. Then we drop the exponent, which is going to give us 2 logarithm of 3 in base of 3. Remember what I said before? If the number and the base are the same, we get a 1. So 2 times 1, that's a 2 that we see there. All right, so at that stage, you can even just write in answer. There's no even need for you to show the working for that, okay? Then if you add these two, that is going to give us 2 is same as in base of 3. Okay, well, let us just use our calculator, guys. It's not like here, even if you use calculator, it's just 1 mark there. So it's just going to add 2 on this answer, which is 10 over 3. So this will be 10 over 3. Okay, so that was the idea there. That was the idea of our question. All right, so you're supposed to be very careful on how you attempt these typical questions that you're given in each and every part. Okay, you're supposed to be very, very careful. So I think that's it. Gonna obtain 3 marks for that. Okay, let's check another question. Let's check another question. Again, they do not want us to use a calculator, but this one, let us just try to have it here. I think this space is enough for this one. All right, the logarithm of 8 in base of 64. Remember, there's a law that I explained. I think you're gonna see that one working. All right, the logarithm of 8 in base of 64 can be written, and the smallest, we can choose the smallest number that can affect these two, which is 2. All right, so 8 can be written in base of 2, which is 2 to the exponent of 3, 64, 2 to the exponent of 6. Like I said, if you do not know this, you can even try with your calculator. At least you know that you are working with 8 and 64, and the number that you can think of there is a 2. So you just have to try 2 to the exponent of which number that can give you 8. 2 to the exponent of 3, it gives you 8. 2 to the exponent of a 6, it gives you 64. So it's a try and error until you get the 64. Then from there, there's a law that I explained here. This one is the one that you're supposed to understand. Remember, I said when you have got here, because we've got the same base, so I'm going to explain in terms of the same base. Remember, I said if you've got log a to the exponent of m in the base of a to the exponent of n, like this, what is going to happen is that you drop this and you also get this here. So you divide the exponents of the number and that of the base. So it will be m over n. And you remain with the logarithm of a in base of a. But the logarithm of a in base of a, remember we said it gives us a 1. So this will be just m over n. So it means here, using the same application, we are going to drop this 3, it multiplies, but this 6 here, it divides. 3 multiplies, but 6 divides. So it means we are going to have 3 over 6, and we remain with the logarithm of 2 in base of 2. But this is a 1, guys, all right? So this is just going to give us 3 over 2. In simplest form, that is 1 over 2. 1 over 2 times 1, as we said, any number times 1 remains as it is. So that one was just going to give us 1 over 2 at the end. And also you can prove these answers, everything. All right, let's start with the first one. Let's try to prove the first one. Remember the first one, 3.11, we got 10 over 3. So you can even prove that one. So you're going to use this, the logarithm in base of 3 of the logarithm again in base of 2 of 512. Whatever that you get here, you must add the cube root of the fraction, this improper. Remember I said this shift, you get it like that. So this is going to be 2 and 10 over 27, like this. All right, so this is going to give us 10 over 3, which is the same answer that we got. It is the same as this one. You can prove on your calculator the logarithm of 8 in base of 64. So the base there is 64, dealing with 8. So this will give you 1 over 2, which is the same answer as the one that we got. All right, so that was the idea of the question. And 3.11, 3.13, we have got the same situation of not using a calculator, but here definitely we're dealing with the numbers and so forth. All right, so there are so many ways that we could have answered this question. The first part on top here is 8x squared y times 6x y to the exponent of 3. So they're going to consider multiplying the numbers together, 8 and 6, which is going to give us 48. Okay, so that is going to give us 48. Then if you multiply x squared and x, they are multiplying the bases which are the same. So remember that you add the exponents. So it's 2 plus 1, which is 3. Gonna add your exponents. Then y and y here, that's y to the exponent of 1 and y to the exponent of 3. This is 1 plus 3, which is going to be y to the exponent of 4. All right, then on this part, there are so many ways. The first one that I'm going to explain is this way. Remember that when you are saying to the exponent, if you're having the cube root, right? If I say the cube root of this x, it means x to the exponent of 1 over 3. All right. If I say the fourth root of x, it means x to the exponent of 1 over 4. So the first way is that we can take it that way to say, but whenever you're giving an exponent, like the number that is inside of the root sign like this, to remove that number, simply divide the exponents by that number. Because by multiplying by 1 over 4, it means you are dividing by 4. So you simply divide by 4. So what am I trying to say? We are going to start by the one that is in the inner one, this one, the one that is inside. Meaning to say the cube root is going to remain as it is. All right, sorry for that. I don't know what's happening with my board, guys, but let's just do PUC. So it's going to be the cube root of, but like I said, to remove this, the fourth root, we're going to divide by this 4 here. We divide by 4 also here on the exponent. So that means if we divide on x, what are we going to remain with? All right, so let us also have our calculator aside at the same time. So on the part of x, because this is on the part of y here, all right? But let us just write in the order of x. This is x to the exponent of 18. So you're going to divide 18 divided by 4. The number that is, you just divide by that number inside the root, which is going to be 9 over 2, okay? So this will be x to the exponent of 9 over 2. You do the same thing on y here to the exponent of 36. You divide by the number inside the root, which is 4. So that is 36 divided by 4, which is 9. So that means the part of y is going to be y to the exponent of 9. Okay? So this is the same answer that you could have obtained if you raised it to the exponent of 1 over 4, then you multiply everything by 1 over 4. Simply divide by the number that is inside of what? Inside of the root sign, we are done. Meaning to say, on this part, again, we can't simplify because there's a cube root, and we're going to consider that the cube root, again, we have to divide by 3 each number. So the part on top is just going to remain as it is, 48, x to the exponent of 3, y to the exponent of 4, everything over. Since we've got a 3 this time, so we're going to divide each exponent here, we're going to divide it by what? By 3. So the part of x is going to be x to the exponent of 9 over 2. We divide it by what? By 3. All right, so that will be 9 over 2. We divide by 3. So let's see, 9 over 2. And then we divide by 3. So this will give us 3 over 2. So that's x to the exponent of 3 over 2. Then the part of y here, we do the same. 9 divided by 3. So that will be a 3, okay? So that's it. And here, we have to divide because now we do not have any square root or what. So you can divide 48 divided by 1, which is 48. The part of x, we are dividing the bases which are the same here. So what are we going to do? We are going to subtract our exponents. 3 minus 3 over 2. So 3 minus 3 over 2 gives us 3 over 2. Okay? So that's x to the exponent of 3 over 2. Then also for y, we are going to do the same thing. We are dividing, subtract the exponent, so it's 4 minus 3, which is a 1, and any number to the exponent of 1 remains as it is. All right, so this is your answer, but you can also simplify this further. Remember, if we have x to the exponent of a over b, it means this is the same as the base root of x to the exponent of a, or everything to the exponent of a. So it means here we are going to have 48, the denominator into the square root. So it's going to be the square root of x to the exponent of 3 times y. All right, so that is how we could have at least simplified far our solution. So having this in mind, remember what I said is that you can also use the same consideration, but in a different manner. All right, let's say I multiplied 8 and 6. I got my 48, just like the previous part, x squared, and x, we got x to the exponent of 3. Y and y to the exponent of 3, we got y to the exponent of 4. All right, but on this part here, I'm going to consider it this way, to say I have got y to the exponent of 36, x to the exponent of 18, which I can write as x to the exponent of 18, y to the exponent of 36, the way that I understand, okay? xy, okay? So the first one is the fourth root. And the fourth root means that we are raising this to the exponent of 1 over 4. That is the fourth root of a certain number or a certain term. We have the cube root at the same time. The cube root means we are going to raise this to the exponent of a third. That's the cube root. So we now have an exponent and an exponent. You see what is happening now? There's now an exponent of 1 over 4, an exponent of 1 over 3. So what do we do? Remember, exponent and exponent can be multiplied together. So this will give us x to the exponent of 18, y to the exponent of 36, everything to the exponent. If we multiply these two, 1 over 4 times 1 over 3, we are going to get 1 over 12. Now that we have simplified our exponent or our exponents, we are still back to those application or same law, because now we have got x that has to be raised to the exponent of 1 over 12, the y to the exponent of 36, which also has to be raised to the exponent of 1 over 12. So it means everything is going to be affected by 1 over 12. We are going to notice our x being raised to the exponent of 1 over 18 multiplied to the exponent of 1 over 12, y being raised to the exponent of 36 multiplied to 1 over 12. The exponent to an exponent. Once you are dealing with an exponent versus an exponent, you can multiply them. So if you multiply 18 times 1 over 12, that was going to give us x to the exponent of 3 over 2. 36 times 1 over 12, that was going to give us 3. So that's y to the exponent of 3. So as you can see, we are back to the same stage, just like the previous method that we used, where we had to simplify each one. But here you can consider simplifying all at once. So as long you are using the laws, as long the laws are being used, you're going to get the same answers. All right, solve for x. So if we are given this is just 2 marks. All right, so we're given solve for x. That's question 3.2. All right, so whenever you're given this type of a question, you can just find the inverse. All right, remember what we want here is to remain with what? With x. So when you are given an exponent like this, you determine the inverse of the exponent. The inverse of the exponent means the reciprocal of the exponent. The reciprocal, what does it mean? It means 1 over that term. 1 over like this. 1 over. That is the reciprocal of minus 3 over 4. So you're going to have minus 3 over 4. This is the reciprocal of minus 3 over 4, which gives us what? Minus 4 over 3. So we are going to raise everything to the exponent of what? The reciprocal, which is the inverse, which is minus 4 over 3, the one that we call the reciprocal, minus 4 over 3. Also, 27 is going to be raised to the exponent of the reciprocal, which is minus 4 over 3. So the reason for us doing this is that we understand that the original number, when multiplied to its reciprocal or its inverse, it gives us a 1. If we multiply negative 3 over 4, which is our original number, to its reciprocal, which is negative 4 over 3, that's the reciprocal, negative 4 over 3. We must get the 1. That is, having 1 means that we are simply having x. So x is going to be 27 to the exponent of what? Negative 4 over 3. So 27 to the exponent of negative 4 over 3. This will give us what? 1 over 81. So this is 1 over 81. That's the value of x. So therefore, our x is 1 over 81. Okay? So that's how they can actually give us these questions of this nature. Okay? So you can be able to evaluate that way. Then on the other part, they wanted us to use the laws of logarithm to determine the value of r if r is equal to this 3.3, and that is 4 marks. Okay, so how do you use the logarithms to simplify that? Because that can be simplified with a calculator, but they're not saying use a calculator direct. We could have just used our calculator, we press our values direct, but they are saying we are supposed to use the laws of logarithms. All right, let's see. Let's see, guys, what are the laws of logarithms that you are supposed to apply. So this was the cube root of 5. All right, this is the cube root of 5 or 652. 652. All right, so that was our question then. No, this was a 2, not a 5. This one, it's a 2, not a 5. All right. That's a 0, 2 like this. Okay. So the question is, we are supposed to use the laws of logarithms, but in order for you to use the laws of logarithms, there must be a log, but we can't see any logarithm here. So that means there's a need for us to introduce the logarithm. There's a need for us. So we are going to introduce the logarithm here. Whatever that we do on the left-hand side must also be done on the right-hand side because it's an equation that you're dealing with now. Okay, no problem. If it is an equation, then that means we're going to apply the laws, but following the concept that the laws should be applied where it is necessary for you to apply the laws of logarithms, okay? So on this part, before you even talk about the laws, you can see there's a lot of things to be done, okay? Yes, we are supposed to use our laws of logarithms, but also considering a lot of things to be done. Okay, let's consider it this way. Put a bracket there. We are dividing, which is true. What is it that makes you to divide two terms like this under a logarithm? What makes you to do that? It is only from a concept that you are dealing with the same base and you were subtracting the logarithms before. That's the only condition that can make us to divide the numbers under the same logarithm. So it is the same thing that we are seeing to say, in order for us to divide, it was only because we had the logarithm of 31,4 minus the logarithm of what we have here, which is 3.02 to the exponent of 5 times the cube root of 652, which is same as 652 to the exponent of a third. Remember, we talked about this issue of the cube root, square root, and so forth. That was the idea. Now we are back. These two, they are multiplying these two. So what made us be multiplying? It was because we were adding the logarithms, just the opposite of dividing. It means we were adding the logarithm. So we had the logarithm of r, which was equal to the logarithm of 31,4 minus the two logarithms here that we are going to be adding, because we are multiplying. So it means we're adding the two logarithms, the logarithm of 3,02 to the exponent of 5 plus the logarithm of 652 to the exponent of a third. That is what it means. We were adding the logarithm. So as you can see, everything here can be affected by the negative. And also, I told you before from those simplifications that whenever you see this exponent, you are going to drop the exponent down. So it means we are going to have the logarithm of r, which is equal to the logarithm of 31,4 minus, you multiply this, everything is just being multiplied, but not forgetting to drop the exponent. So it's going to be minus 5, the logarithm of 3,02 minus multiplies here, it becomes a minus. So that's minus, we drop the exponent, which is a third, the logarithm of 652, of which we could have avoided all this. We could have just worked it straight out from this here to this stage. That was very, very possible. All right, but anyways, for the sake of revision, we saw that our laws can manage to do that. All right, so when they're saying use logarithms, this is what they're trying to say. So what you're going to do is to simplify each, or you can just combine everything at once. It's up to you. Then you use your anti-logarithm to calculate the value of r. So what I'm trying to say is that we can just, this was to 3 decimal places. I'm just going to round off everything to 3 decimal places, okay? So we are going to have the first one. Let's see our calculator here. All right, so the first one is the logarithm of 31,4. Logarithm of 31,4, like this. All right, so this is going to give us 1,46 and so on and so on. We can even round this to 3 decimal places, all right, as per instruction of our question paper. Actually, for the instruction of this one, it was not instructed like to 2 decimal places or 3 decimal places or so forth, but I'm just going to use 2 decimal places, all right? So this is what you're gonna do. You're gonna shift, set up, you go to the fix here on this 6 here, okay? Then to 3 decimal places, you press 3. So it rounds off your answers to 3 decimal places, 3 digits after the comma. So it's going to be 1,497. Okay, so that's 1,497. We do the same thing here, minus 5. So this is minus 5, the logarithm of 3,02. All right. So it's already, it's because it is rounding off my answers to 2 decimal places. I mean to 3 decimal places. So that's why it gives me as what? Negative 2,400. I don't know what was the answer, but it's going to be negative 2,400, like that. We do the same thing on minus a third. That's minus 1/3, which is minus a third of the logarithm of 652. All right, so this was going to give us negative 0,938, okay? Negative 0,938. 38. So thus we can combine everything. So the logarithm of r is going to be everything that we have calculated here, which is this minus 0, whatever that we have, minus this 2, 4 plus 1, 497. Just add up everything, this one that you've got here. And this is going to give us a negative 1,841. So this is negative 1,841. All right, so the idea here is to find the value of r. And our logarithms, this is what they give us. At this stage, we have a logarithm, and we know that if the base is not given, like I always say, if the base is not given, it means you are in base of 10. So in order for you now to find the value of r in this case, you're supposed to use the antilog. The antilog simply means to remove the logarithm, all right? If you check on your calculator, where there is a log, the antilog is the one that is on top, which is 10 to the exponent of. If there is a ln, to remove a ln, you introduce e, which is that one on top. So when there's a log, you remove with 10 to the exponent of the number, right? That is, this one is the log, okay? But antilog is the one on top of that log, 10 to the exponent of. So this is also something that we talked about, even if you do not understand the antilog concept. Remember, I also said if the log base is not given, it means that we're in base of 10. And I said the logarithm of a in base of c is equal to, in base of b, if it is equal to c, it means this a here is equal to b to the exponent of c. So if you understand that, you can also consider to say you are in base of 10. So to find this r here, the one that we have to calculate, it follows that our r is going to be equal to the 10 to the exponent of the answer now that you're giving. You are now removing the log, that is the antilog. So that's 10 to the exponent of negative 1,841. All right, so this is going to give us the value of r in that case, okay? So here we're going to need our calculator. Remember, 10 to the exponent of, we already have this, but we're going to need minus 1,841 like this. All right, so to 2 decimal places, this was going to give us 0,014, okay, 0,014. So that was going to be 0,014 to 2 decimal places. Okay, so like I said, this is something that we could have just used our calculator in the first place to simplify. So that one can be just a proof to see if we are in the right direction, because yes, we have been rounding off our answers, so they are not that exact, but it must be in the same range or in the same interval. Okay, r was equal to this value, which was 31, so you're going to have this as it is, okay? So r was equal to 31,4, 31,4, everything over 3,05. So the 3,02 to the exponent of 5, then multiplied to the cube root. So this was the cube root of 652. So as you can see, we are obtaining 0,014 without using the logarithms, by using the calculator direct. So this is what you can do on your calculator just to prove, to see if you are in the right direction. You can see that, as you can see, the answers are actually in the same interval. That means we are in the right direction when it is like that. All right, so like I said, you might have your questions sometimes that way. Just have to be very, very careful. I think that's it. Now on question number 4, was 11 marks on everything. Let's try and see 4.1 we are given, it's from our solid shapes, whereby we are given a statement that a lead cylinder is made by melting a rectangular circular cone of perpendicular height. All right, so a lead cylinder is made, we had a right circular cone and it was melted to give us a cylinder, right? Okay, so that's something like this. A right circular cone, this one, all right, sorry for the diagram. All right, something of this nature, and we understand that you're gonna have the slant height, the perpendicular height, this and that, the radius, and so forth. So we have to melt this to give us what? A cylinder in this case, to give us a cylinder. So what is it that these two are going to share, which is the same if you melt a cone, and from what you've melted, it gives you a cylinder? What is it that you must consider there? It is the volume, all right? So whenever you are talking about or you are referring to a solid, whenever you're dealing with solids, you melt one solid, you create another solid, they are going to have the same volume. All right. So if they have the same volume, it means their volumes are equal. Remember the volume of a cone? The volume of a cone is given by what? A third pi r squared h. You know, we are given this formula. And yet the volume of a cylinder is given as pi r squared h. When one is melted, this and this will be equal. Okay, we shall talk about that. So what are they saying here? They're saying we melted a circular cone of perpendicular height 9 centimeters. So the 9 centimeters is on the cone. All right, remember this is the perpendicular height. So h is equal to 9 centimeters on the cone. Given that both shapes have the same radius and the height of the cylinder is equal to its radius. Okay, the first thing is that both the shapes have got the same radius. So it means here we've got r, our radius, and here also our radius is the same. So they are saying radius is equal to radius of this cylinder, of this cone to the radius of this cylinder. But further on, they are mentioning about the cylinder also in further detail, that the height also, and that the height of the cylinder is equal to its radius. So they're also saying this height that we are supposed to have of the cylinder is equal to the radius. So they're equal, this radius, and this height, they are of same, they're equal. That is what we are simply saying. All right, anyways, not a problem. So the first question was to prove that the base radius of the cylinder equals to 3 centimeters. All right, so they are simply saying prove that radius is equal to 3, whether it's for a cylinder or it's for a cone, because we said both have got the same radius. The radius of a cylinder and the radius of a cone are the same. This cone and this cylinder, they've got the same radius. That is what we are told there. All right. So in order for us to determine, because we need to prove that the radius is equal to 3 centimeters. Remember what I said about a solid, one solid that has been melted to give us another solid. I said they have the same volume. So from the concept of the same volume, it is then going to follow that from the concept of the same volume, we are going to see that the volume of a cone, the one that we melted, which is a third pi r squared h, is equal to the volume of the cylinder, which is pi r squared h. But there's something that we are told here, that this radius and this radius of this side, they are the same. So if they are the same, it means these two, we are simply talking about the same thing here. We are simply talking about the same radius, all right? And on the cone, we have the height, which is 9. So we are going to substitute here. Let's substitute and say, I want you to see something that is just clear. A third times pi r squared times the height, we are given that the height is 9 on the cone, is equal to pi r squared times the height on the cylinder. Now, on the cylinder, remember this is the formula for a cylinder. The height is equal to the radius. So it means our height is going to be written as r, because we said that the height is given as the radius. We are given that. But if you are to consider these two are the same, pi r squared, pi r squared. So you can even divide by 1. If you divide by pi r squared, this will cancel each other. So we are left with 1 over 3 equal to 9. 1 over 3 times 9 equal to what? Equal to the radius. So the radius is going to be 1 over 3 times 9, which is what? Which is 3 centimeters. So that's it. That was the question to prove that the radius is equal to what? 3 centimeters for that, okay? Then calculate the surface area of the cylinder in square centimeters, all right? We need the surface area of the cylinder. Remember that we got that the radius is what? Is 3 centimeters. So if it is 3 centimeters, it means here I've got 3 centimeters. And remember I said the height is equal to the radius. So it means also this height is equal to what? 3 centimeters. So the question needs us now to calculate what? The total surface area in that case. All right. So for a cylinder, we are also given our formulas, everything, the surface area being 2 pi r squared plus 2 pi r h. Or let me just try to do this so that you can also see your formulas. But as we know that we are given this part here. All right, I want you to check this part. On a cylinder, this is the surface area, all right? So it's going to be 2 pi r h, 2 pi r squared plus 2 pi r h, okay? So it's 2 pi r squared plus 2 pi r h. So this is the one that we are going to substitute into here. This is the one that we are going to use and to substitute from there. So that's 4.12. So our surface area, as we saw from our formula, it was 2 pi r squared plus 2 pi r h. So here it's just a matter of simplifying, substituting everything. We got that our radius is what? 3 centimeters on the on each part. So it's going to be 2 pi r squared, which is 2 pi times 3 squared, right? Plus 2 pi r, which is the radius, which is 3. The height, remember I said the height, we are given that the height is equal to the radius. So the height is also equal to what? Is also equal to 3. So that was going to give you the surface area. So you can be able to simplify this. Let's see how we're supposed to obtain our final solution here at the end. So it's 2 pi. That is 2 pi times 3 squared. Then we are going to add 2 pi in this case like this, times 3, which is just 3 squared, all right? Times 3, which is 5, which is 3 squared. This is just one and the same thing. So this was going to give us 36 pi, all right? So we're gonna have our area as 36 pi square centimeters, all right? Or we can simplify this. If we change this, that will be 113.097. 113.097 square centimeters. So that can be your area, which is the surface area of what? Of the cylinder. All right. We also ought to find the surface area of the cone again in square centimeters. There was also 2 marks. Okay, no problem. So for the cone in this case, remember now that we calculated the radius and we got that our radius is what, 3 centimeters. Remember the radius of the cylinder is the same as the radius of the cone. So it means also here we have the radius of the cone in this case. Having the radius of the cylinder gives us the radius of the cone, 3 centimeters. So on the cone, just because we do not have this slant height, if we had our slant height, we know that our formula for the surface area, okay, this is 4.13. Let me just write it. The formula for the surface area was supposed to be pi RL, right? It was supposed to be pi RL plus pi r squared of the circle that is below here, the curved part and the circle. But because we do not have L, we can calculate L from our Pythagoras theorem, whereby we understand that L, being the hypotenuse, will be the square root of h squared plus r squared. So meaning to say, in place of this L, we can just substitute our formula as it is pi r into L, which is h squared plus r squared plus pi r squared. You're also given this formula in your formula sheet, but I also wanted you guys to check where it is coming from. So that is another way that you can just have your surface area directly, because you are given this, guys. You have the formula, so you just take the best formula to use. So this is going to be pi times r, which is the radius, we said is 3 centimeters, times the square root of h squared plus r squared. Our h, remember, is the height, which is 9 squared, plus the radius squared, which is 3 squared. So this is a single part, plus pi r squared, which is the radius squared. So this is a 3 squared, like this. All right. So that was going to give us the surface area. So whenever you are working with your solids, consider your formulas and also understand the meaning of the formula. You must understand the meaning of the formula that you are given for that particular question. All right, so if you have to simplify this direct, let us just try to have it direct on our calculator. Let's just open bracket. So this will be pi. So it's going to be pi like this, times 3 times the square root of 9 squared plus 3 squared, like this. All right, so you're going to close the bracket, plus pi. So this is pi times what? Times 3 squared. All right, so this was going to give us 117,686. Okay, if you round off direct, that's gonna be 117,686 in square centimeters. Remember, this is area, and area is going to be measured in the square units. Okay, if you're talking about area, but here we're given they're in centimeters, so it means we must have our answer, or you're supposed to write our answer in what? In the square centimeters, okay, for area. So that was it. Then we move on to question 4.2, which was they wanted us to also apply that area from our irregular shape. So we've got the coordinates of an irregular metal plate in millimeters are as follows. So these are the ordinates. All right. So the question was, calculate the common interval of the ordinates if the area of the plate. All right. So these are in millimeters, and we're given the area in square millimeters. And what we wanted was the common interval, the difference between. Remember how we obtained area. We said area is obtained if you add the first ordinate to the last ordinate. All right, so you're going to be able to add the first ordinate to the last ordinate over 2, plus we're going to have the sum of the other ordinates. Then here you're going to concern sum of the other ordinates, which is the remaining ordinates in this case. Then we multiply to the what? To the distance that is between what? The distance between the ordinates, which is the distance. So this distance that is between the ordinates is the one that they want us to calculate, the common interval. So maybe you can just write your common interval as x or h, whatever letter that you want, all right? But what you just need is to substitute. We have the area, we are given everything. The area is given as 21,135. So this is going to be equal to what? We are going to add the first ordinate and the last ordinate. So this is our first ordinate here, and this is our last ordinate. So we add these two together. So that is 120 plus 118, everything over 2 like this, plus the sum of the other ordinates, which is the remaining ordinates. We're going to add all these ordinates up to the last one. So we have got 125. So that's 125 plus 135 plus 140 plus 145 plus 160 plus 155, all right, plus 150 plus 145, and the last one, which is 135, all right, so it's going to be plus 135, sorry. All right, so we have got 135 there. Okay, so these are the ordinates that the remaining one. But like I said, we must multiply to the distance between these what? The distance between these ordinates. We can just maybe call it x, okay? Just call it x, then you can simplify further. All right, on the left-hand side, there's nothing to be considered, okay? But here you can consider this, then you add everything, all right? This is what you can do, all right? So meaning to say, we're just going to rewrite what we had on the left-hand side as it is 21,135 is equal to, if you just simplify these two, only these two, 120 plus 118 over 2, we get 119. All right, plus we add up everything here, these ones, these ones, these ones, these ones, these ones. If we add everything there, we are going to obtain 1,290. Then multiply to x, which is our distance. Then from there, guys, as we can see, we are now left with a normal equation that we can add these two. We get 1,409x. So to find x, we're going to divide by 1,409, both sides, 1,409, both sides. So therefore, our x, which is the distance between the given interval, the given points, was going to be 15. If you divide these two, you're going to get 15. And remember, we are given that these dimensions are in millimeters. So that means that was going to be 15 millimeters, okay? So this is how we could have answered this question. It just needed us to apply the basic approach that we know about our area from the irregular shapes, all right, from our area, from those irregular shapes and so forth. Okay, then we had a function on question number 5, all right, that was a function with functions, in this case, f of x. We are given the function of f of x, which is minus 6 plus x squared, and gx minus 2, x minus 3. And there you are asked to copy and complete the table in your answer book. So what they are simply needed you was to redraw this table as it is, okay? So it was just a matter of substituting on the part of f of x, this one. We substitute the values of x to obtain the values of f of x, which are the y values that we are simply talking about, all right? So how do we do that? We just substitute. This is your f of x. So put it properly on the calculator. I'm just going to teach you guys. You put it this way. Let's show each other the calculator. So this is -6, okay? -6 plus x. X represents whatever that you're going to substitute. So you open a bracket for that part. All right, just like, let's give an example here. Our x was -4. So you put inside the bracket -4 like this, plus x squared. So you plus whatever that you substitute you must open a bracket. So this is again at -4. All right, to the exponent of what? To the exponent of 2. All right, so this is what you're going to have. Okay, because here we fixed our calculator, remember, to 3 decimal places, it gives us 6,00, but you're supposed to change that. So it's shift, set up, you go to the normal mode on 8. So 8, then you press 2, back to the normal mode. So the number there is a 6, which is this one. So that is how you get the next term. When x is -3, just substitute, because already you know that inside the bracket is where I substitute. Now I have -3. So I'm going to remove this and put -3. I do the same here. I put a -3. So you're going to get a 0. All right, you do the same thing when it is -2. Just have to substitute, just go back there, remove a -3, put a -2. All right, also here where there's a 3, we put a 2 so that it becomes -2. That's a -4. So you're going to do that and so on up to the last term. You're just substituting back on your calculator. So at -1 and so on. At -1, we're going to obtain a -6. At 1, you are going to obtain a -4. At 2, you are going to obtain a 0. At 3, you're going to obtain a 6. So it is the same thing on gx, okay? On gx, this is your gx. So you also have to do it the same thing on your calculator. So this is how you indicate your gx. It's -2x, so it's -2x, you open a bracket, okay? Just for example, when x is -4, you put -4, close the bracket, -3, like that, okay? So that's 5, which is this 5 here. So it means the next term for x is -3 on gx, on this gx, if x is -3, I'm just going to substitute -3 inside the bracket, put -3, that will be a 3. When x is -2 inside of the bracket where there is x, I put -2, that is going to be a 1. So you're going to do this and so on up to the last term. So this was going to be -1, -5, -7. When x is 3, it was going to give us a -9. So I want you to try that, and you see that you're going to have the same table as what I am having here with you guys. All right. Then the other question on 5.12, it was use the graph paper. All right. So here we need a graph paper here to draw the graphs of f of x and gx on the same system of axes, that is on the same graph paper. The one that you're going to draw gx is the same graph that you're going to use to draw your gx, okay? So let's see, if you are to check this table here, our values, they are supposed to be taken from -4 to +4 on x. But on the y values, the negative one, it's -9, and here there's a +14. So you must be thinking of those values to say they are supposed to be appearing, they are supposed to be part of your what? Your graph. All right, so let us see on our graph paper if we can be able to see this part together, guys. I just need the graph paper. I just hope I put the graph paper here. All right, let me just remove this one. All right, sorry for that, guys. I just need this graph paper. So maybe we can be able to see properly. So, like I said, this is your graph paper, and the graph paper that you're using in exam, it's actually something that is very, very limited, okay? Once it's limited the way it is, make sure that you are able to separate in a way that you can accommodate the x values, all of them, and the y values, all of them. All right. So this is what I'm just going to do. On the x values, I'm just going to use the scale of 2 centimeters. I'm just going to make like the whole box to represent 1. I'm saying the whole box, I'm referring to the combination of you see, these are 2 boxes here. Let me show you. This one, like here, it's a box of 5. 1, 2, 3, 4, 5. So me, I'm going to use 10 boxes like this, 10 of them to represent 1. Okay, I hope you are catching me up. Then going on the y, because remember on the y, we need to get 14, we need to get 9. So it's going to be too big. So I'm going to take it that way. I'm just going to take it that way to say the 10 boxes also here, they represent a 5. Maybe that way it can work, a 5. So you must be able to also analyze this scale. If we are going this way, we're going to use 1. If we are going this way, we're going to use a 5, -1, -5. So this is the scale that I'm just going to use. At least it can help us to accommodate everything in that case, because there are bigger values on the y, and we have to consider those bigger values on the y. All right, so let me take this ruler, the one that I actually want here, not another thing. All right, so this, I'm just gonna try, guys, to make this as fast as I can so that you'll be able to move together. So something of this nature, like this. Okay, so I can even name my points like something of this nature, right? So it's just gonna have to label this as our x-axis, and this we can just put our 0 there. So remember what I said here, I'm going to use 1 for each after 10 boxes. So you count 10 boxes, then you put a 1. That's what I'm going to use on the x. So this will be 1, and this will be my 2, this will be my 3, and this will be my 4. Okay, just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which represents a 1. So it means the smallest box is 0,1, something like that. Okay, I do the same thing on the negative, on the x, 10 boxes again. So it's going to be somewhere here, -1, -2, -3, -4, of which you can just use something that you are capable. You can just use 1, 2, 3, which is fine, or the smaller box here. Okay, you can just use the smaller box like 1, 2, 3, 4. It'll be somewhere there. -1, -2, which you can also able to apply it that way. Okay, but yeah, I just want you to properly see. Also going up, you can even choose to do that way to get to remember we said the highest number there was, but it was going to maybe 2, 4, 6, 8, 10, 12, 14, meaning to say we're going to have it somewhere there. All right, but I just want us to have this in a way that we understand. Okay, so if we are to take it this way, like I said, as for me, I'm just gonna use 5, but I think 5 is gonna be also too big, because here we can also consider 2, 4, 6. Okay, like 2, 4, 6, half of it, but still even the 5 is fine. Okay, or you consider 2. All right, so let us just take it this way. There will be 2 here, and this will be 4, because I want you to see this. If we take it, this box, there are few 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you won't be able to reach 14, and also here won't be able to reach other values. That's why I'm saying if we can be able to use 2 for it can be at least closer to what we want. Okay, not that closer to what we want, but it can be at least a little bit closer. All right, so let us just use 2, 4. 2, 4, 6, 8, 10, 12, 14. All right, -2 this side, -4, -6, -8, -10. I think it can accommodate all the values. Then it is gonna be too much stretched. So, okay, sorry for that. I can even reduce this one. Sorry for that. I can even reduce this one because my graph is going to be too much spaced. My graph is going to be too much spaced, of which is not a problem, but it's going to be too much. So let me just write 1, 2, 3, 4. Let me just use 5 boxes. -1, -2, -3, -4. All right, something of this nature. Okay. So this is what we are having. On the x-axis, everything, we've got 1, 2, 3, 4, 5 boxes representing 1. Okay. On the y-axis, 1, 2, 3, 4, 5 boxes representing 2. So it means 1, it is in between 1, 2, in between 2.5 boxes represents what? A 1. So this is how you're going to take your points. You have to analyze that way. And here, I don't think we've got the commas that can affect, so there's nothing that can affect us. All right, so this is how you're supposed to mark these points, because you have these from your f of x and gx. So you're marking the points corresponding to each other. I'm not going to waste much time. I'm just going to show you from this f of x. You are taking the x value at -4 and the y value at what? At 6, like this. It's a point. X is -4, y is 6. So you have to mark where these two meet. When x is -4 and y is being what? A 6. So this is somewhere there, -4, and y is a 6, somewhere there on top. You mark your point. You do the same thing. When x is -3, y is supposed to be equal to 0 on f of x. So on f of x, -3 is at 0. All right, this is what you're going to see on our f of x, -3 versus 0. If y is equal to 0, always in the what? In the x-axis. So the point is at -3, 0, like that. You do the same thing and at -2. So it's going to be a continuation, -2 versus what? -2. So you're going to do that again. So that's x -2, y being at what? At -4. All right, so that's -2 and -4, not -2. Is it -2 or -4? Let's check. -2 and -4. Okay, the same thing, -1 and what? And a 6. -6, -1 versus -6 here, -1 on x, y being -6. So you're going to do that, guys, like I said, and so on and so on. So if you consider the following point, it was 0 versus -6. So this is 0 versus -6. You mark your point here. The next point was 1 and -4. So it's 1 versus -4. The other one was 2 and 0. So that's 2 versus 0. 3 versus 6. The other one was 3 versus 6. And we had 4 versus 14. We are taking on what? On f of x. So the other one was 4 versus 14, which is somewhere there. All right, so those were the points that we're going to mark after that on your graph paper, because you're asked to use the graph paper on this one. So with these points, you're supposed to draw this a quadratic graph, as you can see, guys. Highest exponent is 2, so you're going to have a quadratic graph there. So we are supposed to join our points smoothly and properly from one point to another. From this point, we are going to join to -3, goes to this point. As you can see, there's going to be, there's going to be a turning point there. You're going to have a turning point somewhere there. Then it goes to -6. All right, so that's something like that, guys. Just try to have it as a smooth curve, as a smooth curve, something like that. So that's something of that nature, even though mine is not that smooth, okay? So you're supposed to have a smooth, very, very smooth curve to represent what? Your function of f of x, which is a quadratic function, in that manner and is supposed to be smooth. So this is our f of x, all right? So that is our f of x. So you do the same thing on your gx, all right? The same thing, you're going to do it on gx. So on gx, we are given also the points there on gx, all right? So you're going to consider those points that we're being given, all right? Sorry for that, guys. I don't know what just happened. I need these points here on my gx. So on gx, we've got the points -4 now is going to correspond with 5. So you're taking the same way, -4 now corresponding to what? To 5. So you must mark a point where -4 and 5 meet. All right. What happened here? Sorry for that, guys. Sorry for this. Sorry for this one, guys. Okay. Okay, so software, guys, you know, this software is what they do. Okay, so I'm saying the -4 must correspond to +5, which is this one, all right, on x. All right, so x is -4 and y is +5. So you have to analyze, where are we going to have a +5 on the y values? Where are we going to have a +5? Remember, on our analysis, we said that these 5 boxes represents 2 on the y. So 1 is the half of the box. So if this is 4, this is -4. Here we are at 4, and here we're at 6. So we just need in between, which is 2.5. We're going to count 1, 2 boxes, and a half in between. So it must be 2.5 box. At -2, you mark at 5, which is in between 4 and what? In between 4 and 6, all right? So this is what you're going to do throughout the points that you are given. After -4, the next point is -3. This one, -3, which is versus 3 this time. So you're going to mark those points corresponding each other, -3 and 3. So -3 here, and 3 is in between 2 and 4. So you're going to count 1, 2, 2.5. So just in between, 2.5 in between. So you're going to have that a continuation. If you check on your gx, the next point, it was -2 versus 1. So -2 versus 1, which is in between 2, 0 and 2, that is 2.5 boxes. -1 versus -1, that is, we are going down 2.5, 1, 2.5 box. That's -1, -1. 0 versus -3, that's 0 versus -3, somewhere there. 1 versus -5, which is just below -6, but 2.5 boxes, 1, 2.5, that's -5. Then we had the 2 versus -7. So those are the points that you're marking, 2 versus -7 in between. Then we've got 3 versus -9, 3 versus -9, and the last point was 4 versus -11. This would be -12 somewhere here, and -11, it's in between these 2 points. All right, so as we can see, we are marking points on our graph paper here. We are marking points, but after marking these points, we are supposed to join them. This is a straight line. Y is equal to mx plus c. We are referring to what? To a straight line to be drawn. So we are just going to use the ruler. This time we use a ruler. The last graph that we worked with, we do not use a ruler on that one. It's drawn by freehand. But this one, we are supposed to use our ruler, joining the points that we marked. So you just need a ruler like this, and we are supposed to smoothly join our points. All right, so like this, I'm going to join them like this. All my points are being joined together. So that means we have got the function in this case of gx. So that is our gx, which is the straight line, which was the graph of -2x minus 3. All right, so that was what the question wanted you to do on the graph paper like this, not in the answer book, but on the graph paper. All right, it's a different question when they are saying sketch a graph. Here they wanted you to draw. That's why they to give you the table of values with everything on that table of values. So you're supposed to have something of this nature at the end. All right, let's see the other part of the question. I think on the drawing part, we are there. Then now, that was 5 marks actually to draw this. Then 5.13, use your graph in 5.12 above to estimate. So take note, estimate. These are not exact values. So you're not supposed to be given an exact answer. They just take an approximate value from what you're going to get, all right? Where of which gx is equal to f of x. Remember, gx is equal to f of x at the point of what? Or the point of intersection. And they said you must use broken lines to indicate those points. So if you're to be where they intersect is somewhere there. So you're gonna join approximately, that was at negative 3,8, approximately somewhere there, negative 3,8, and on this side, approximately at 0,8 or 0,75 or 0,85. So remember, it's an approximation. We are approximating whatever that we are doing here. It's an approximation. It's an estimate value, because remember, our graphs, they are not that smooth as it's supposed to be like, all right? So it's just going to be an approximate. So according to our estimate value here, it's going to be somewhere around negative 3,8, and the other x value somewhere around 0,8 or 0,75, somewhere there. All right. So that was the hint to use the broken line, which is what we did. Then 5,14, calculate the equation of the axis of symmetry of f of x and draw it with a broken line on your graph in question 5.12 above. All right. So remember the equation that we have on the axis of symmetry, we are also given from our formula sheet, which is given as x is equal to minus b over 2a. So that is the equation of the axis of symmetry in this case, all right? So 5.14 x is equal to minus b over 2a. From our f of x, remember, we are supposed to have this in the form of ax squared plus bx plus c. So that means we're going to have this as x squared, all right? X squared plus x minus 6. So this is x squared plus x minus 6. So you can properly see where we have our a and where we have our b in this case, okay? So meaning to say our a is 1, our b is 1. So our x at the equation of, at the axis of symmetry, our x is going to be taken as, right? Just gonna need this one, sorry for that. X is going to be taken as minus b, our b, which is 1, over 2a, our a, which is 1. So this is negative 1 over 2, which is same as a negative half. Negative half, which is same as negative 0,5 if you want to have it as a what? As a decimal. So x is equal to minus 0,5. But it is not just determining this. They also asked you to draw that axis of symmetry, the line, okay? So we are going to draw that on our graph. X, we want to, the line of x is equal to minus 0,5. X is equal to minus 0,5. It's in between. Remember, 0,5 on our x is in between here. 2 boxes, 5 boxes represents minus 1. So minus 0,5, it's 2.5. Gonna count 1, 2.5. In between 2.5, in between 2 boxes. Okay, 2.5, because there are 5 boxes there. So that's where the point is. At that point, what you need is to draw a straight line at that point, because this is where we have our x being equal to what? Our x being equal to negative 0,5. So at this point here, you draw a line, but they said a broken line. So this line must be broken, all right? We must have a broken line. That's the axis of what? of symmetry, this line that we have drawn, this one. So you can even write the equation on that line. X is equal to minus 0.5. You can even write our equation on that line, which is the broken line. All right. So that was our question there. That was our question. Then 5.15, calculate the y-ordinate of the turning point of f of x. Remember, at the turning point, the x value is the one that is the same as the x that we have at the axis of symmetry here. At the turning point of your graph here, the x value is that axis of symmetry that you had. So we are simply going to substitute that. Okay, the question is asking for the y value at the turning point. So we are going to substitute our y value into our f of x. Our x value, this one, at the axis of symmetry into our f of x, so that we give the y value. All right, so that's 5.15. So you're going to substitute. Remember, it reads that f of x is equal to minus 6 and this and that. So you're just going to substitute everything as it is on that f of x here in our f of x. So we are substituting the x, that one that we got on the axis of symmetry. So that gives us the y value there, which is y is going to be minus 6, all right, plus x. So that's plus our x value, which is minus 0.5. Okay, sorry for that, minus 0.5 plus x squared. So we're going to add x squared, which is minus 0.5 squared. So that's minus 0.5 squared. That's minus x squared. So we are just substituting as it is. So by substituting this, it gives us the value of y at the what? At the turning point. That was what the question is asking you to do. Okay, so let's see on our calculator what we're gonna have, but in this case we're supposed to have something like negative 25/4. All right, that you can just substitute on our calculator here. That's negative 6 plus negative 0.5 plus, open the bracket, negative 0.5 squared, like this. Okay, so this gives us negative 25/4, which is same as negative 6.25. So that's negative 6.25. So that's the y value or the y ordinate at the what? At the turning point. So at the turning point, the x value is the one that we had from our what? From our axis of symmetry. That was our x value. The x value there is the one that you simply take. All right, so it was the same situation or the same scenario that we had on this question. Again, 5.2, we are given a condition where they wanted us to exactly use our graphs to draw these ones. Okay, so anyway, copy and complete the table below in your answer book. So you're going to take this table. So Vx is the graph of minus sine x, and Wx is a function of what? Of cos x, all right? So they are saying here we are supposed to copy and complete. So Vx, we are simply substituting on minus sine x, okay? So you're going to take minus sine x in this case, okay? So let us have our calculator and make sure that your calculator is in degrees. So that's minus sine x. Like here, if our x is a 0 like this, we put a 0 like this, we close, it's a 0, okay? This is what we have as 0. So to have this, the following one, minus 30, minus 30 at minus 0.5 is the same. So you're going to move on to 60, 120, 240, 300, 360, substituting on what? On sine x. All right, so on 60 degrees, just substitute here in place, put a 60 here. This will give you minus square root of 3/2. So as a decimal is 0.8666. Let us just have to one decimal place. All right. So to one decimal place, shift mode. We fix this to one decimal place, which is going to give us minus 0.9. So this is minus 0.9. At 120, we do the same thing. Just have to place 120 here. That's the same answer, minus 0.9. So guys, we're going to do this throughout, substituting at 240. You have it as a positive 0.9. At 300 as a positive 0.9. So that is what you're going to do on the wx, the function of wx, this one, which is the function of what? Cos x. So cos 30, you substitute there, you're going to get a 0.9. Cos 150, you substitute, you're going to get a negative 0.9. At 210, negative 0.9. At 330, it's going to be a positive 0.9. So it was just using your calculator there. All right, then on 5.2, to use the graph paper to draw the graphs of Vx and Wx on the same system of what? Of axis. So you're supposed to plot this from 0 to 360. And if you check this time, we have a lot of values that you're going to consider there. A lot of things that we have to consider from 0 to 360 degrees on our angle, separated by 30. This time they want us to separate by 30. But if a question is like that, you don't find the question, you have to use as it is, right? So no problem. Let us just try to have our graphs and see how it was supposed to do. So as you can see, our graph is supposed to be more on the positive, more on the positive on the x, okay? So let me just have what I'm trying to say. Okay, something of this nature can actually work. So if you check how I spaced these ones, maybe it can just make some sense here. On the x, I'm just going to use 30, 30, because it's separated 30, 60, and so on, okay? Then going up, I'm just going to use 0, 0.5, 1, okay? Minus 0, 0.5 minus 1. So it means this is 0, 0.1, 0, 0.2, 0, 0.3, 0, 0.4, 0, 0.5, 0, 0.6, 0, 0.7, 0, 0.8, 0, 0.9, 1, okay? So that's how you can actually, so each box represents a comma 1, 0, 0.1, 0, 0.1, 0, 0.1, like that. Okay, so just like the previous case that we saw on those two graphs, we worked with 1, 1. So we're going to work with 1, 1 also on this one. Let's start with Vx, which is minus sine x. We've got 0 versus 0. So you're going to mark our point, just like the previous case, 0 versus 0. So that's 0 versus 0 here. You mark your point. You move on to the next point. That's 30 versus minus 0, 0.5. So this is 30 versus minus 0, 0.5, okay? So 30 versus minus 0, 0.5, you mark your point, okay? Okay, sorry for that. I'm going wrong direction. I want that one. So it was 60 versus minus 0, 0.9, okay? 60 versus minus 0, 0.9. Let us just confirm, but the rest, I'm just going to show you guys direct this one. 60 versus minus 0, 0.9, right? So that's 60 versus minus 0, 0.9. You mark your point also. Each and every point has to be marked, okay? 60 here versus minus 0, 0.9. Remember, I said each box represents 0, 0.1. So 0, 0.9 is just before minus 1. So that's where we have a 0, 0.9. So like I said, guys, we're going to do this throughout up to the last point, okay? So the next point was 90 versus minus 1, 90 degrees versus minus 1, 120 versus minus 0, 0.9, which is somewhere here, 150, which was versus minus 0, 0.5, 180, which was versus 0, 210 versus 0, 0.5, which is on top here, 240 was versus 0, 0.9, all right, 0, 0.9 just before 1. You do the same thing on 270, 270 was versus a 1, which is there. 300 versus 0, 0.9, 0,9. Remember your 0,9. Okay. 330 versus 0,5. And 300 was versus a 0. So those are the points that you're supposed to take into consideration. You mark them properly on your graph. With these points, you have to join them smoothly. You are supposed to have the function of this sine x, each point joined correspondingly. All right. So that is what I was expecting you guys to have your answers as, something of this nature. Okay. They will award you full marks for this. Full marks. Just try to have your graph in a smoother way. Okay. So that was the graph of Vx, which is the graph of what? Of negative sine x. This is the graph of negative sine x. So we are going to do the same thing on the graph of Wx, which is the cos x. So we are going to have our points just like the previous case, okay? 0 versus 1, that we are now on Wx. So it's 0 versus 1. So we're going to mark our point. 0 versus 1. This is 0 versus 1. You mark your point. The same thing and so on. 30 was versus what? 0,9. 30 versus 0, and so on and so on. Okay. So this is where we have 30 here. 0,9 just before 1 box just before 1. Okay. So this is what you're gonna do, guys. You mark your points and so on. 60 was versus 0,5. 60, this is 0,5 here. 90 was versus a 0. 120 was versus minus 0,5. 150 was versus minus 0,9 just before a minus 1. At 180, that is where we were at minus 1. At 210, it was minus 0,9. At 240, it was at minus 0,5, just directed minus 0,5. 270 versus a 0. 300 was versus a 0,5. 330 was versus a 0,9 on top there. 360 was versus a 1. So this is the graph of cos of x. And we know this graph, guys. All right, we actually know this graph. But yet they wanted us to do it in another way where we have to like properly draw it. Okay. So mark your points just like the previous case. After marking your points, you have to join them. So by joining these points, we are completing our trigonometric function for the graph of what? For the graph of cos of x. All right, so this is our turning point then, like this. Okay, so that was the graph of Wx, which was equal to the graph, which was equal to cos of x. So your graphs, they were supposed to be somewhere like something like this. This is how I was expecting your graphs to be like. Graph of Wx and the graph of what? Vx, okay? So it's a matter of, guys, understanding your graphs, okay? Just understanding how to play around with the graphs and so forth. Same situation, just like a quadratic and a straight line. Then from there, they're saying 5.23, we are supposed to read from your graph. Your graph is the one that you're supposed to, it's actually an estimate, because remember our graphs, they are not as smooth as we are expected to have. All right, but we are supposed to read from that graph of yours above, in question 5.22 above that we drew, the values of x for which Vx is equal to Wx. Then hint, use broken lines on the graph paper to read off the x values. All right, so we want a condition where Vx is equal to Wx and is only at the point of intersection where these two graphs can be equal. So we need at the point of intersection of these two graphs here, where these two graphs intersect at the point of intersection, what is the x value there? At the point of intersection, what is the x value there at the point of intersection, where they intersect? That is where Vx and Wx are the same. So in order for us to read up, we have to consider now the issue of the scale, guys. We have to consider the issue of the scale. What does it represent? So this one can be approximately one box, maybe, sorry for that, what is happening here? One box maybe approximately a 5 or a 6, which is something like a 5. So here's going to be 125, 130, 135, somewhere like that. So it's going to be something like 135. So like I said, it's an approximate. It's not like you're going to have the exact answers. You're going to be marked out of a certain interval. Okay, it's a certain interval that you work with, so it's not going to be approximate. So it's going to be approximated something like 135 there, and 305, 310, 315 approximately there, approximately 315. Okay, so this can be approximated to 315. So meaning to say 5.23, we can just say our x value is approximated at the point of intersection at 135 degrees, or another x approximated there at 315 degrees. Okay, so that is what you're supposed to have on this question. The values of x at the point of intersection, that's where the two functions are equal. You consider where the two functions will be equal. That is the condition of what? Of your question. So if you consider this issue of graphs, you can see that, yeah, it was actually nice that now they want you to actually draw and see the exact part. It's not like that part where we just sketch our graphs. Okay, you have to draw exactly the graph. You have to draw your graph, understand your graph, each and every part that is happening on that graph. I think that's the last part of our question actually here. All right, question number 6. Okay, let's see what we're given. Convert 6.1, that was actually 2 marks. So we're asked to convert 13.4 rads to degrees and minutes. All right, so we know that pi radians is equal to 108 degrees, okay? So if we are given 13.4 radians in degrees, it means how many degrees do we have? That is if pi represents 108 degrees, what about 13.4? So it can be just a simple proportion that you can make. So it's going to be this one over this. Okay, what we want to calculate is the one that you write on top. So it's going to be 13.4 on top over pi times the angle in degrees, because you're supposed to convert to degrees. Okay, so if we do this, let us just see our calculator also here so that we can just have our values. So that is going to be, okay, I'm just going to take this decimal here, 13. Let me remove this fix and go back to the normal mode. Okay, so this is 13.4 over pi, in this case like this. You're going to multiply to 108 degrees like this. Okay, so it gives us the angle, which is 767 degrees. This is the whole number here represents the full angle that you're going to have, which is 767. So we have got 767 degrees. Then you convert the remainder, which is the decimal. So you remove this whole number, 767, this one, just subtract it, 767 like this. As you can see, you remain with the decimal 0, that. So this is the one that you convert to minutes. Remember, the relationship between degrees and minutes is that 1 degree is equal to 60 minutes. So to convert this decimal to minutes, you just multiply it by 60. So this is going to be 45, this and that and that. So you just take the whole number, the whole number is going to be 46. So it will be 46 minutes, okay? So that's it, 2 marks for that. If you want to convert further, you can do that. 6.2, we are given that the arc length of a sector is given as 12.5. So there we've got the arc length 12.5 centimeters, and the angle, that is the angle sector subtends at the center of the circle is 1.25 radians. All right, so you're given the arc length and also the radius, the angle at the sector in that case. All right, so this is 6.2. So we just have something of this nature. That's our sector. So it is having a length, this our arc here. Remember, this is our arc. So the arc length, there is the one that you're given, and you're given that it has a length of what? Of 12.5. That is the arc length, 12.5 centimeters. And the angle here, which is our theta, is equal to 1.25 radians, which is measured in what? In rads. So we're given the arc length and what? The angle. 6.21, calculate the following. On 6.21, the radius of the sector. So you can calculate the radius of the sector. If you take it from the formula sheet, I want you to understand this. From the formula sheet, this is how they gave you. All right, let me just try and see. I think this one here. All right, this is how they gave you from the formula sheet. They gave you this formula as sector. All right, on the sector, theta is equal to arc over radius. I want to explain from that formula. Theta, the way they gave you, so that maybe I do not confuse you, because I was going to confuse you. Theta is equal to arc over radius. What are they trying to say if they are saying theta is equal to arc over radius? Let us save it here. Theta is equal to arc over radius. They are simply giving us the formula for the arc length. If you just cross multiply this, you've got the arc. So it means the arc is equal to the radius times theta. If you multiply the radius and the angle theta, you get the arc length, which is the arc. Where they write the arc, they mean the arc length. And I told you guys that theta like that must be in radians. If they give you in degrees, you convert to radians. So this one is already in radians. So it's just a substitute. Remember, we want to calculate what? We want to calculate radius. All right, so this is 6.21. So we're going to substitute the arc length we are given. 12.5 is equal to, we do not have the radius, but we've got our theta in radians, 1.25. So we want to find radius, so you divide, since here we are multiplying, so you're going to divide by 1.25 both sides. So this gives us the value of the radius. We are going to remain with the radius in that case. So if we divide this to 12.5 divide by 1.25, you're going to obtain 10. So that was going to give you 10 centimeters, okay? So that was your radius in that case. And the next question on 6.22 was to calculate the area of the sector in square centimeters. So if you check also from your formula sheet, we have the formula for the area of the sector, which is half r squared theta. So this one is for the area. Whenever you're dealing with the sector, area is given by half r squared theta, where theta is in radians, okay? So since we calculated the radius, we now have an advantage because we're just going to substitute. So 6.22, our area, as we saw, that it's half r squared theta. So meaning to say our area was going to be half times the radius squared, which is the radius, which was 10 squared, times theta, which is the angle in radians, which is of what? 1.25, as it is in radians. You don't convert it to degrees. You only convert if they gave you in degrees, you have to convert to radians. So that was going to give us an area of 62.5, yeah, something like that, 62.5 square centimeters. So definitely it's going to be square centimeters, since the radius is measured in what? In centimeters, okay? So that was it on question 6.2. They just wanted you to understand the idea of a sector there. As you can see, it was a direct question. This time it was a nice question paper, actually. I don't want to lie, this was a nice question paper. 6.3, Now they are giving us that a wheel is an angular velocity. So we've got an angular velocity of 150 rad per second. All right, remember angular velocity is omega, like this. This is omega. All right, so that's 6.3. We are given omega, which is 150 rad per second. All right. Then the question was to calculate, in this case, we're asked to calculate the number of revolutions the wheel completes per second on 6.31, per minute on 6.32. All right, so how do we calculate the number of revolutions completed, which is n? There we want to calculate n. So if you check also from your formula sheet, there's a relationship that we have between this omega and this n, okay? What is our relationship, okay? I want you to check here on angular velocity. Angular velocity, omega is equal to 2 pi n. So I'm gonna explain that formula. What does it mean? If we are saying omega is equal to 2 pi n. All right. The angular velocity in rad per second is equal to 2 pi n, whereby this is the speed in revolutions per second, that is revs per second. So meaning to say, we can calculate n from this formula. We can make n the subject by substituting, or by just dividing by 2 pi both sides, by 2 pi both sides, so that we remain with n, because we want to calculate n representing our speed, okay? Okay, so our n in that manner is going to be given as omega over 2 pi. So this is omega over 2 pi, like that. So like I said, if this omega is in rad per second, it means n will be revolutions per second. That is the idea that you're going to just use there. So that was what we're going to do. So 6.31, n was going to be equal to omega, which is 150 rad per second over 2 pi. So the moment we use the rad per second, it means this n is going to be in revolutions per second. So that was going to be 223,873, something like that, revs per second, okay? Then on 6.32, they wanted us to just have the same speed, but now in revolutions per minute. So it was just a conversion that you're just taking here, because already you have this per second. How do you convert this to revs per minute? You just multiply by 60. So if you multiply this by 60, we get revolutions per minute. Remember your conversions, guys. So that was going to give you 1,432,38 in revolutions per minute. That is revs per minute. So these are the revolutions that we're going to be made per each minute, okay? Let's see the other part. 6.4, this question, let's see. They are saying here, let's save it properly. Given that the diameter of a circle is twice the length of the chord of the same circle. All right. Calculate the length of the chord as a function of the height. As a function of the height, meaning to say in terms of the height there, of the segment created by the chord, as a function, like in terms of the height. Calculate the length of the chord in terms of the height. Okay, that is what they are trying to say there. All right, there's this formula that we know, and it's better that we've got the formula sheet, so I'm just going to explain something that you can also properly see and we understand each other. On this formula here, they are saying, okay, here, on the segment of if you're dealing with segment of circles, the chord length is given as x, the height of the segment as h, the diameter as d. Then the formula that can be used to connect these three is given as d is equal to h plus x squared over 4h. All right. This is what the formula is stating. No problem. Let us take our formula and the information that you're given and try to make this clear. Okay, the statement here that you're given is that the diameter is 2 times, that is twice the length. All right, the diameter is given by D, remember, we said the diameter is given by D. So this is 6.4. So if the diameter is given by D, they're saying is twice the length of the chord or the chord length, and the chord length is given by what? By X. Remember, we said X there represents the chord length. This is our chord length. All right. And the height, we are not even told about the height, which is the height of the segment. Okay. That is what they're saying here. We are supposed to write or to calculate the length of the chord. What is the length of the chord? The length of the chord is X. But you're supposed to calculate it as a function of the height, meaning to say in terms of h, because we do not have that h. So whatever that you're going to calculate, which is the chord length, which is x, we must calculate it in terms of h. So this is what the question is simply trying to say here. Calculate the chord length, which is x, in terms of what? In terms of h. How so? How is that possible? All right, let's take down our formula. We saw that our formula was given as D, the diameter, is equal to h, which is the height of the segment, plus x squared, which is the chord length, over 4h from our formula sheet. We have D in terms of x, because here we need our answer to be x in terms of h. So we must remove D and write it in terms of x. And D in terms of x is 2x. So it means 2x is equal to h plus x squared over 4h. Okay. We can clear our fractions in this case. There is 4h. This is same as over 1. Over 1. So you can just multiply everything by 4h. The LCD by 4h also here. So that will be 4h times 2, which is going to be 8. So you're going to obtain 8hx, like that. Okay, so that's all, 8. Okay, which is equal to h times 4h, which is going to be 4h squared. So this will be 4h squared. 4h and the 4h will cancel. You remain with the x squared. So as you can see, remember, we are supposed to solve for x. We are supposed to calculate for x. And we have actually formulated a quadratic equation because the x is being raised to the exponent of 2. So that's a quadratic equation that we are supposed to think of writing it in the form of ax squared plus bx plus c is equal to 0, where I told you that one of the side must be equal to 0. So ax squared, which is this x squared here, bx, which is where there's x here, which is our b is 8h. So you're going to take this to the other side. All right, so the definitely is going to be a negative there. All right, this was a positive, so 0 is equal to x squared. We take this, the one with h is going to be negative 8hx. 4h squared, there is no h here, as there's no x here. As you can see, we do not have x. So if there is no x, it means that is a constant. So the 4h that we see here is our constant. So we're just going to write it as 4h squared. The constant, there's nothing to be added or to be subtracted from it. So this is the equation that we have at the end, which is a quadratic equation, like I said before. So we can be able to solve this equation the normal way, because we are supposed to have x in terms of h. And for us to have x in terms of h, we're going to solve our equation, because this same as x squared minus 8hx plus 4h squared is equal to 0. So from our quadratic formula, we understand that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a from this formula that we have. If we have written our equation in this format, And this is the same format that we have. So we just have to see that, okay, this is the coefficient of x squared. What is affecting x is our b in this case, and the constant, which is 4h. So this is our a, this is our b, this is our c. So that means we're going to solve properly our equation. X is equal to, okay, we are solving for x, minus b, that is going to be minus our b, which is 8, which is minus 8h. Okay, plus or minus the square root of b squared, which is our b, minus 8h squared, minus 4ac, our a, which is 1, our c, which is 4h squared, like this, okay? Everything over what? Everything over 2a. So this is 2 times our a, which is 1. So as we can see, we are solving for x, and the answer is in terms of what? The answer is in terms of h. Okay? Gonna have your answer in terms of h as a function of h. Okay? Minus, minus, that's a plus. We're gonna have plus h, plus or minus the square root of. So if you have to simplify, you're gonna see that there's a negative here, negative 16, negative 8 squared, which is a 64. Then h also is gonna be raised to the exponent of 2, so it'll be 64h squared, okay? Minus, if you multiply this 4 times 4, that will be 16h squared. Then we can subtract 64 minus 16, which is going to give us 48h squared. So it means the whole of this part under the square root is going to give us what? 48h squared, everything over 2 in this case. That is 2 times 1, which is a 2. All right. So if we had to simplify, we were going to see that we can't determine the square root of 48, which is the actual sense about it. We can't determine the square root of 48 direct. All right, but let's see what we're obtaining from our calculator, okay? Let's see what our calculator is giving us. This is our calculator here. We've got 8h in this case, and this, so we just want to focus on this one only, the square root of what? Of 48, like this. This is 4 square root of 3, okay? So it means you are going to have x being equal to 8h plus, I want you to be careful here. The square root of 48 gave us 4 square root of 3. So this is 4 square root of 3. What about the square root of h squared? This one, we can obtain the square root of h squared is h. Remember, a square root and a square, they cancel each other. And this is everything over 2. Or another x was going to be the same thing, 8h minus this time 4, the square root of 3h in this case over what? Over 2. Remember, guys, what I told you about having everything in the denominator affected by the same number. It means everything is going to be divided by 2. So if we divide by 2 here, what are we going to have? That is the question. 8 divided by 2, that is going to be 4h. 4 divided by 2, which is going to be 2 square root of 3h, okay? You do the same thing here. X is going to be 8 divided by 2, which is 4h, minus 4 and 2, which is going to be 2 square root of 3h, like that. So that was going to be x in terms of h as a function of h. We've made x the subject of the formula in terms of h. So they do want you to understand this. You can even simplify this, add to this term. If you simplify 2 square root of 3, like you can even add like this, because this is h and this is h. So you can even add 4 plus 2 square root of 3, 2 square root of 3, like this. It gives us 7,46. You can even write it that way. There are so many ways of having this final answer that we are seeing. Okay, but the major part of the question, I hope we do understand, okay, that we were supposed to formulate an equation that we are supposed to solve for what? For x. But as we are solving for x, we must solve it in terms of h, because we do not have that h. If we had h in terms of maybe h, it's a certain value, we're going to obtain exact value of x. But that's why here they are saying we are supposed to write to calculate the length of the chord as a function of the height, meaning to say the answer is supposed to be in terms of what? The height. All right, 6.5. Given that the sine of theta is negative 8 over 17 from 270 to 360. If we are given it like this does not make sense, because already we know that it's a negative, and 270 is just one interval. They already gave us the interval. So this one was a direct person, because you're already told from 270 to 360, there is no other quadrant that has got 270 and what? And 360. It is just one quadrant. So in terms of question asking, that is why I'm saying it does not make sense, because we're supposed to be just given that, and you are given another condition, then you are the one who is supposed to figure out which quadrant is it. But it was an advantage on our side to be given it that way, because we understand that is 0, this is 90, this is 180, this is 270, this is 360. So this is what I'm trying to say. There is no other interval that we have between 270 and 360 besides this one. That is the only quadrant between 270 and 360. So already they've told us where we are supposed to have our solution and how are we supposed to even present this solution. So it was just to our advantage here, guys. All right. Anyways, no problem. Let us write, or remember, we're going to have our triangle like this. It's a right angle triangle, and the angle is taken from here up to here. This is the angle that we're going to take. So we're given the sine of theta, and we know that sine theta in this quadrant is what? It's a negative. Remember, from your cast concept, this is your cast. Okay, here cos is only one, which is positive. Other ratios, they are what? They are negatives. Okay, but that one was not a matter of fact, because already they told you about this a to say the sine of theta is minus 8 over 17. So what does it mean? It means that we can present it on our diagram. If the sine of theta is equal to minus 8 over 17, as we know that the ratio of sine is simply taken from our mnemonics, the SOHCAHTOA concept, the SOHCAHTOA. The sine being the opposite over the hypotenuse. It means this is our opposite over the hypotenuse. So according to this angle, this is our opposite here, which is negative 8. The hypotenuse, which is this side, which is what? 17. So that is our hypotenuse in this case. Okay, that's it. So meaning to say, we can be able to calculate whatever that we want. In this part, we can calculate the third side, because remember, it's a right angle triangle. So you can even calculate the third side in this case, because whatever the question is asking us here to determine the value of 1 plus tan squared theta without using a calculator, we are supposed to fill in our diagram first, this, all right, because we are supposed to calculate the value of 1 plus tan squared theta. And we know that tan is opposite over adjacent. According to this angle, we're going to need the opposite and we're going to need the adjacent. And as you can see, we do not have this adjacent. So that's why now we are forced to use our Pythagoras theorem to calculate the third side, since we are on a right-angled triangle. So c squared is equal to x squared plus y squared, or you can have it as r squared for this hypotenuse. 17 squared is equal to x. This is the x value that we want. So it's going to be x squared plus the y value, which is at minus 8 squared. So that's, we're going to simplify 17 squared. That is something like 289 equal to x squared plus 64. Then transpose 64 to this side, it becomes a negative. So it will be 289 minus 64, which is 225, is equal to x squared. So you can determine this by putting the square root both sides. So x is going to be square root of 225, which is plus or minus 15. So that's what you're going to have there, right? Sorry for that, guys. Let me put it this way. So we had, all right, no problem. We had the square root there. That was x squared, okay? So x is going to be the square root of 225, which is plus or minus 15, like I said, is going to be plus or minus 15. But now you check the side. On this side of the quadrant, on x, it's on the positive. This side is on the negative. So this x here is going to be taken as a positive value. We're going to have our x as a positive. So let's simplify this now. They are saying we are supposed to simplify 1 plus tan squared theta, and we said the tan of theta is opposite over the adjacent. So we are supposed to have this as 1 plus tan squared theta means the tan of theta squared. So we're going to square the tan of theta, which is the opposite over the adjacent. So the opposite is -8 over the adjacent, which we said is 15. But this has to be squared. We are supposed to square it. Okay? So that was the whole part of the question. So we can square this -8 over 15. This one, you can even use a calculator. That state does not even matter. So that will be 64 over 225. And if you add these two, you're going to obtain 289 over 225. So like I said, from that stage, use your calculator. It does not even affect anything on your solution. Okay, so that is how they can ask these questions. That is how they can actually ask these questions. All right, 6.6, we are given, we have got two tall buildings in this case on the same height, of the same height. All right, two tall buildings of the same height are 20 meters apart. So there are two tall buildings which are of the same height and they are 20 meters apart, as shown in the diagram below. From some point A, which is from this point, supposed to be the same point. All right, one of the buildings, all right, on one of the buildings, the angle of elevation of a dove D at the top of the other building. So here, this D is a dove in this case. D, we are talking about a dove that is on the top of the building. Okay, so it's on the top of the building. Okay, then calculate the height of the buildings. Okay, if from the same point A, the angle of depression of the base of the other building is 47 from the base. Okay, from the base here, the angle of depression, this is the building. So from the base of the building, meaning to say this is the top. So we are going to refer this one here. This is what they want. Okay, the angle of depression is 47. So here we've got 47 degrees. The angle of elevation here is 27. All right, so in actual sense, this one is actually a wrong statement because here they're saying, calculate the height of the buildings. All right, the first building that we have, we can see it because they're saying there's a dove here at the top of the other building, 27, meaning to say it's limited to this point. This is the height of the building, this one. The second one, it's limited from the bottom here, the base, up to the top, which is M to B, so or BM. So these are the two buildings that we consider from M to B, and from D to M, it's another building, it's another height of the building. They can't be the same because if you check, they are separated 20 meters and different angles taken to the base. So these buildings, they are not of the same height, all right? So that was supposed to be from a certain point, like from the same point, not to say the buildings are of the same height. That one, it's an error that just happened there. All right, so in actual sense, that is our question, but we are not supposed to say they are of the same height. No, that one is a lie because here we can consider they're different angles separated. All right, so how do I calculate from D to M, which is the first height? This is 27. So this angle is going to be opposite, all right, this side is going to be opposite, and we have got the adjacent. So you just need a ratio that is going to use the opposite and the adjacent at the same time. There's only one ratio that uses opposite and adjacent from our SOHCAHTOA. From our SOHCAHTOA, opposite and adjacent is on time. So we're going to have our ratio the tan of theta, which is the angle of 27 degrees, is equal to the opposite, which is the side that you are supposed to calculate, the height of dm, over 20, which is the adjacent, which is 20 meters. So to find dm, we can just cross multiply 1 times dm, that is dm is equal to 20 times tan 27. So this is 20 tan 27 degrees. Okay, so this is going to give us what? dm. Okay, sorry for that. So if we simplify properly from our calculator, 20 tan 27 is going to be something like 10,191 meters. So that was the first height of the building. Then we move on to this building here. This is its height. So according to this one, 47 degrees, the part that we are given according to 47, this is the opposite that we have. And this side is the adjacent. So again, we have got the same ratio for tan that we have to consider there. As you can see, we're going to consider the same ratio. The tan of theta, this time the theta is the angle inside the triangle 47, is equal to the opposite, which is side that we want to calculate, which is dm. This one is now from this point to this point, which is b. That one is now bm. All right, it's unfortunate that I covered up, but this is a b, so it's gonna be to point m. So it's gonna be bm over the adjacent, which is 20. So that's it. You can use your trigonometrical ratios to calculate the side. Over 1, cross multiply 1 times bm. That is going to be bm is equal to 20 times tan 47, which is 20 tan 47 degrees. So bm in that case, which is another building, was going to give us 21. It was going to be 21,447 meters. Okay, so this is the height of the other building. So together now, the height of the buildings, now if you are considering the total height of these buildings together, we have to add their difference. We have to add the first one and the second one. That is, we have the total height of the building. So the total height will be the sum of these two, which is 10,191 plus 21,447, which will be something like 31,638 in meters, something like that. So guys, you see, it's just important that you understand how to operate with your formulas in trigonometry. It's very, very, very important in your trigonometry for you to understand your formulas. All right, so that was a total of 100 marks in this question paper, guys. Let us just try to share this video. Let us share to our friends and colleagues, and also join the membership platform, especially for those who are going to advance next year for mathematics N3. Make sure that you join the membership so that you won't miss any of the revisions that we shall have for the N3, N4, N5, up to N6 for our mathematics. So make sure that you become part of the membership family by joining through any one of the videos or by clicking join, so that you'll be able to be part and participate as other members in supporting us to have as much content as we can to you guys. But I want to thank you guys for those who are part of the family and all our subscribers. Let us continue to share our videos to our friends and colleagues so that they become part of the family of MedZone African Motives.